Hi guys, a very good evening everyone. Welcome to all the GATE 2024 champions, and it's today the last lot of GATE 2024 examination. Yes, the GATE 2024 last lot for electrical students has been finally conducted at 5:30 p.m. The paper is over. Okay, and we have got some basic analysis about the paper. We have already started receiving them from the students, so we are going to present you that basic analysis, and also we'll be presenting you the different questions we have received. Let's discuss that one by one. Sir.
Yeah, we know that you are all curious about how the difficulty level, what are the answers to the questions. We keep getting the questions already, and we will show you the solutions and the answers also. Before that, you may be curious about how many MSQs, how many NATs, how many MCQs. That details are also we have already received. We got that information from our students live from the centers. Some of the students shared the questions also. So we'll show you directly. First, let's go to overall difficulty level. You guys also please keep sharing it to all the students and ask them to join and also share what is your opinion about the paper. Is it difficult? Is it moderately difficult, or is it easy? Or it is in between moderate to difficult or easy to moderate? Your opinion also matters us to conclude that whether it is too difficult or overall difficulty level, how it is. We already got some information that we are updating here, but we'll keep updating with the more and more data if you are sharing. So this is the information, first-hand information we got. Rakesh, over to you, and let students know what the paper weightage is.
Yes. So, guys, 7 MSQs in EC. We got 8 MSQs, but okay, they're also
Looks
good
like
number.
must be wrong, must be correct.
Yeah.
Because more or less EC electrical goes in a similar way.
Similar way. So we have 7 MSQs, 23 NATs, and 25 MCQs, and of course 10 from GA. That is always fixed. GA they are giving only MCQs, so that is why I've separated it. So out of the technical, this is the distribution: 25 MCQ, 23 NAT, and 7 MSQs. This is what is the weightage of the distribution of the 55 questions. Very soon, Sanjay Rathi sir will also be joining, and along with that, Ishan sir, Chetan sir, entire team will be joining very quickly in front of you. 10 questions of aptitude, and all are MCQs as always. And the difficulty level, it will be too early to say right now. We'll be taking your inputs also, but as far as I know, the difficulty level, that it's relatively tough. Okay, till now, this is the update, but let's wait. We need more sample space to comment on the difficulty level. But, till this time, what is the information we are getting is a difficult paper.
Yeah.
Right. So, yes, sir, we can talk about more data, but I think let's get also started with the questions.
Yeah. We have received some questions already. We'll start solving it as quickly as possible because you're also maybe waiting for these solutions. One question from analog. I don't know how the difficulty level of overall analog subject, but few questions we have received. We keep solving one by one. The first question is on BJT. This is the question given. I don't know how many marks it is for, but just we got the information that BJT is given with a resistor of 1K connected at the emitter, and here is 2K resistor connected, and this is given 12 volts and supplied with this. This is 100K and it is 50K. Beta is given 100. Asked to find Q point. Asked to find Q point. This is the most expected question. Anytime, in every analog circuits class, we keep discussing these circuits in the biasing part. Hope you all guys must have done this. This is not so difficult question, but if you know how to solve it, then only it is easier for you. If you don't know the basics of Q point and biasing, then it is difficult for you. Always we say this circuit can be solved in two ways: exact model and approximate model, using Thevenin's method and using approximate method. And remember guys, asked is to find the Q point, and this is the potential divider network. You all know, right? Isn't it? It is a potential divider circuit, biasing circuit. The name of the biasing circuit is potential divider. So what is Q point? Obviously, Q point is nothing but the values of VCE, collector to emitter voltage, and the collector current flowing in the circuit. So the current flowing here, how much is the current flowing here is IC, and the voltage between collector and emitter is called as VCE. So we just need to find this voltage and current. That is what biasing point is. Come on guys, keep sharing this information to all of the students. So let other students also join and know whether this is given in the examination or not, because we got it from some of the students shared in our database. And also please confirm the details, resistor values, potential difference applied, the battery connected here, 12 volts battery is given. And I'm not sure whether it is a MCQ or NAT question. I'm not sure about it. But we have to find these values. So I'm going for approximate method because we don't know whether it is MCQ or not. See, if you want exact values, always better use Thevenin's theorem and then solve it. If you want to just pick the answer from the options available, always I suggest the approximate method. Go for the approximate method. So what is approximate method? Assume IB is equal to 0. The current flowing this side, let us assume it as 0. Then this base network becomes open circuit. It is like an open circuit for you. When it is open circuit, the voltage here we can call it as VB, can be found by using potential divider formula. So VB, I can find it as 12 volts into the same branch resistance is 50K by total resistance 50 plus 100 is 150K. So K got cancelled. So 1 by 3 it is. So it is 4 times. So VB, the base voltage is 4 volts. Voltage at this place is 4 volts we got. Then what is the next step to do? You need to find the emitter voltage here. Emitter voltage. What is emitter voltage? Assuming this transistor is not given in the data, maybe in the examination it is given. If it is germanium transistor, take it as V gamma as 0.3 volts or 0.2. If it is silicon transistor, it is not mentioned here. V gamma will be 0.7 volts or 0.6 volts. So I'm assuming it is silicon. It is not given. Generally, we assume it's silicon. So the voltage at the emitter, VE, I call it as, is equal to VB minus V gamma. So I'm assuming silicon. So it is 4 minus 0.7 volts, which is 3.3 volts. So the voltage here is 3.3 volts. Correct, guys? Are you following? So if you have any questions, please keep commenting on the comment section. If the emitter voltage is 3.3, what is the current flowing in the emitter? Can I call it as emitter current IE? So that is nothing but IE is equal to emitter voltage divided by emitter resistance. How much is that? 1K. So it is 3.3 volts divided by 1K is 3.3 milliamperes. Once emitter current is 3.3 milliamperes and assumed base current is 0, so collector current is also going to be same as emitter current. So I can take it as IC approximately equal to 3.3 milliamperes. In fact, IC will be slightly less than emitter current, but since we assumed it as an approximate method and we are going for approximate values, slightly difference will be there. That's okay. So 3.3 milliamperes is the IC. So we got this on this point. Then VCE to be found. What is VCE? It's very simple. VCE is nothing but VC minus VE. We already know what is VE. Here we found it. VE is this. We already found the VE value. So once VE is there, we need to find VC. So VC is what? The voltage here. So VC is equal to VCC minus the drop across this resistor, isn't it? So it is IC into RC, I'll call it as. So it is 12 minus IC, we got it as 3.3 milli into RC is given 2K. K and milli got cancelled. So how much is this, guys? Can anybody say? I don't have the calci with me. Can anybody say this? What is this? Let me check the comments. Yeah. Come on, guys. So it is 6.6. 6.6. 12 minus 6.6 is 5.4. Right now? 6.6. Yeah. 5.4 volts it is. This is VC. Now VC is 5.4. VE is 3.3. So it is 2.1 volts. 2.1 volts is VC. So the Q point we got is 2.1 volt, comma 3.3 milliampere is the Q point. This is what the question for. Hope it is correct, guys. Sanjay sir, are you there? If you have any other questions received, can you please join the session? By the time you guys have any questions, please share me, guys. And if you ask me questions, I can discuss.
Yes, I have one question, sir, on CMRR operational amplifier.
Yeah.
And this question we have discussed in just previous session, sir, in MSQ.
Wow, that's great.
Same
Super.
question.
That's great. Super.
तो वो भी बताएंगे सर लिंक उसका भी अब सॉल्व
Yes, sir.
करते हैं दिस वन that
Over
is
to
one
you, sir.
guys, one question in for CMRR that that differential amplifier by using ideal op-amp, it is given here. Okay, I'm going to draw this diagram and then we will solve this. Okay, and check the data. Right, that is a similar question we have. This is the minus plus. Now that value is given as 101. This is the RF, and then this is the 10.5. So what is the answer, guys? What is the answer for this question? What is the CMRR? In just previous session on MSQ, I have discussed this question. Same question I have discussed. This is the CMRR. We have to find that is the 955K 101. This is the 10.5 101K. Okay, right. Now in this question, simply you have to check RF by R1. RF by R1 is equal to R3 by R2. This is R3, this is R2, this is RF, and that is R1. Right? But this ratio is not equal. RF by R1 is not equal to what? R3 by R2. It is visible here. Means the CMRR is not infinite. CMRR is not infinity. AC is not zero. That is called common mode gain is not zero. Now I have given you the shortcut. In that case, you have to find the V0 is equal to, in this diagram, V0 is equal to, the standard answer is 1 plus RF by R1. That is the gain 1 plus RF by R1 into R3 upon R2 plus R3. R3 upon R2 plus R3 into non-inverting terminal voltage, that is the V into, minus RF by R1 into what? V in 1. Okay. And that value is what? A1. And this is what? A2. That is nothing but V0 is equal to, this is the A1, V1, A2, V2. So what is the A1 here? If you are saying A1, V1 plus A2, V2, now you can compare. This is the non-inverting voltage. This is the inverting voltage. So what is the A1? This value is A1. So what is the value of the A1? You can find 1 plus RF by R1, 101 upon 101 upon 10.5. Now you can use the virtual calculator also. And then what? Into R3 upon R2 plus R3. R3, 101.5 upon 9.5 plus 101.5. Right? And that is the value of what? A1, guys. That is the value of A1. Similarly, what is the value of the A2? Now you will get the A2 is equal to minus RF by R1. So minus RF, 101 by 10.5. 10.5. Now you can calculate it. Okay. Now please go use your virtual calculator and calculate these values. I have got these values. Please check my calculation also. That is nearly equal to 9.71 and 9.62. If 9.7 and 9.62 we are getting A1 and A2, then in this question, what is the CMRR? AD by AC. CMRR is AD by AC. And what is the AD? AD is equal to A1 minus A2 by 2. And what is the AC? AC is equal to A1 minus A2. A1 minus A2. Then after that, you can put the mod here, so that you can find the AD and AC, and then finally what? CMRR. What is the value here? Now find the A1, then find the A2, and then you can find. So, okay, tell me guys, what is the answer for this question? How many students use this method? Tell me. तो अभी और भी क्वेश्चंस हम लोग लेकर आएंगे, और अगर ये तो हुआ मेरी तरफ से एनालॉग में क्वेश्चन, ये बड़ा इजी क्वेश्चन था एनालॉग में. आई थिंक यू हैव सॉल्व दिस क्वेश्चन गाइज. यस प्लीज. क्या आया आप लोगों का आंसर? वन मिनट. Okay. Now guys, just to calculate it, just I am using the calculator, my calculator, and I am going to calculate it. That is, देखो यहाँ पर ना पहले ना फ्रैक्शन में आने दो. फ्रैक्शन अगर आ रहा है 1010 अपॉन 105, तो ये आ जाएगा आपका 101 डिवाइडेड बाय 10.5 प्लस 1, and that is equal to 223 by 21. This one. 223 by 21 into, and that is, क्योंकि देखो वर्चुअल आपको अगर डेसिमल में लाना है, if it is what numerical answer type question, then you have to check. Then 101.5 divided by, this is the 111, right? 111 guys. Now this is the 203 upon what? 222. That is the value. Okay, now you can, now this is the value. 101 divided by 10.5, and you will get 202 divided by 21. 202 and divided by 21. Now you can calculate this value and you can find the answer. So hope you have solved this question. You are getting 9.71. Yes, this is the 9.71. 202 divided by 21, that is equal to 9.62. 9.62 with minus sign. 9.62 minus sign. So 9.71 means 9.71 minus of minus 9.62 divided by 2. You will get AD nearly equal to that value. AD आएगा आपका आंसर. तो ये आ गया 9.71 plus 9.62 divided by 2. You will get 9.665. This is the AD. This is the AD. Then what is the AC? 9.71 minus 9.62. This is the plus actually. This is plus 9.62. And this is 0.0909. 1 minute. 0.09, that is 9 by 100. Now get the ratio of that. 9.665 divided by 0.09, and you will get 107.38. 107.38. That is the CMRR. If it is asked in dB, guys, if it is asked in dB, then you have to find the 20 log of 107.38. If it is asked in dB, then into 20, and you will get around 40 dB, nearly equal to 40 dB, 40.619 dB. So yes, it's up to you. Then what is the answer, everyone? If you have any idea, that is asked in what dB, or that is asked in what simple number? Simple number, or that is in dB, guys? Tell me. Comments में आ जाइए, जरा बता दीजिए. तो ये एक क्वेश्चन था. आई थिंक ना अब दूसरा क्वेश्चन देख लिया जाए. ओके, राकेश सर कोई आप आ रहे हैं?
Okay, dear. Okay, so let's have some questions to be discussed now. Starting off with a simple one. Okay, one from the Boolean logic, and then there are signals question, maths, control system. I have some, miscellaneous questions here. Okay, the first one, starting with the basic one, simplify. Okay, simplify the expression P bar Q bar plus, and also guys keep verifying whether you found this question or not. P bar Q bar plus P bar QS plus P Q bar R bar S bar. Okay, plus P Q bar R S bar. Okay, no need for any K-map. It's a basic simplification. Okay, yeah, we'll overall comment whether the paper is lengthy or not. Let's solve some more questions and then we'll come to a solid conclusion here. So come on, guys. What about this one? If I take P bar common, then you have Q bar plus QS. Okay, and Q bar plus QS, we know that should be Q bar plus S because this is the complement of Q. X plus X bar Y is X plus Y. Okay, the complement will be omitted here. Okay, now from these two terms, definitely P, Q bar and S bar common, R bar plus R, that's equal to 1. Okay, so we are getting the expression now P bar Q bar plus P bar S plus P Q bar S bar. Okay, I think these two further can be simplified. इसको separate रखेंगे. Okay, so Q bar again common and then P bar plus P S bar. Okay, P bar plus P S bar. P will be omitted. Okay, it will be P bar plus S bar. Okay, P bar plus P S bar. So this is now equal to P bar Q bar. Okay, again opening up. Okay, plus P bar S plus the last term that is Q bar S bar. That is Q bar S bar. Yeah. If you just rearrange it, now have a look into this. Let me start from this way. Let me start SP bar plus S bar Q bar. Okay, plus P bar Q bar. Isn't it like consensus now? Okay, isn't it like consensus? We'll comment on the cutoff and all. Let's discuss some questions, Shweta, before that. Okay, isn't it like consensus? Okay, I can call it as A, B plus A bar into C. A, B plus A bar, A की जगह S है, into C plus BC. Plus BC, P bar Q bar is like BC. So it should be AB plus A bar C. Okay, so the answer is, okay, it should be SP bar. The BC will be omitted. Okay, that will be redundant term S bar Q bar. Okay, we have the 4 options also. Let me write down the options for you. Okay, there were 4 options given, and out of that, yes, P bar S plus Q bar S bar itself is the correct answer. P bar S plus Q bar S bar itself is the correct answer. Then there are some options. Sir, क्या करना है options का भी आगे बढ़ते हैं. Option number A itself is the correct. Other options are not correct. Okay. चलो. So guys, moving ahead to the next one. ये एकदम simple से start किया. Okay, now let's pick up the next one. Whatever I get in the sequence. All right, so there is an angle of departure. So I told you digital signals, control, EMFT, maths. Okay, I have 4 or 5 subjects right now with me. Okay, सभी के कुछ ना कुछ question है. So let's take this question from control system. Okay, a very basic one, expected type है. Okay, K S square minus 2S plus 2 open loop transfer function is given to you divided by S square plus 2S plus 5. Am I right? Yes. Okay, find the angle of departure. Okay, angle of departure for the pole that is -1 plus J2. Okay, -1 plus J2, angle of departure. Right, everybody, did you attempt this question? Sir, one control SM questions option were totally wrong, Kali Charan. If you have that question, state model question you are telling. If you have that question, share me in the Telegram. Okay, I'll also check in my list. I've got a list of questions with me. Okay, but ऐसा कोई question है जिसमें ambiguity है तो please share me in the Telegram. I'll be just checking it after this. So dear, if I just write down the zeros, so what's going to be zeros? Okay, it's going to be minus of minus 2 plus minus root over b square. Okay, minus 4ac. Okay, divide by 2. So zeros are 1 plus minus under root of minus 4. That will be 2. So plus minus j2 2 cancel kiya. Okay, let me write down the poles for this function, and that's going to be minus 2 plus minus root over b square minus 4ac. So 4 into 5, that's basically 20. Divide by 2a, so that's going to be -1 plus minus, this is 16 and j4, so divide by 2 j2, so -1 plus minus j2, that is what is the pole they are mentioning. 1 plus j, -1 plus j2 पे निकालना है. Okay, so now let's check out. Okay, let's have a quick geometry here. Okay, so what are my zeros? -1 1 plus minus j, and poles are -1 plus minus j2. Okay, these are the poles, -1 plus j2, -1 minus j2, and zeros have -1 plus 1 plus j and 1 minus j. Okay, this is our pole of interest. -1 plus j2, इस पे angle of departure निकालना है. I hope you all remember the method. Okay, we'll be joining this pole. Okay, with respect to all the other poles and zeros, let's do it geometrically. It's always easy to do that. Okay, let's do it geometrically in that case. Okay, now the angle is also towards this particular pole. Okay, so the angle of departure, okay, the angle of departure will be given by the formula 180 degree minus phi p minus phi z. Okay, you have to confirm me whether the k was positive or negative, and if by chance nothing is given, k will be positive. K is positive given. Okay, so that means it is the regular root locus, not the complementary root locus case. Otherwise, the formula would be different. So 180 degree minus phi p minus phi z apply karenge. Phi p sum of angle with respect to other pole. The other pole is conjugate, so that is appearing in a vertical line. 90 degree is the phi p. What about the phi z? For phi z, there are two zeros, so I have to calculate the angle with respect to both phi z1 plus phi z2. Now ये angle कितना होगा? इसके लिए थोड़ी सी ज्योमेट्री हम अप्लाई करेंगे. Okay, look into this. How much is this angle? Okay, how much is this angle? Okay, for that एक छोटा सा calculation यहाँ पे कर लेते हैं. Geometry let me solve separately. Okay, this is one point, and this point is 1, 1 geometrically, and this point is -1, 2. Okay, when you join it, this is -1. Okay, how much will be this angle, dear? Okay, तो यहाँ से phi z1 निकालूंगा. How much is this angle? Please note that. Okay, 180 degree minus the interior angle, because angle is with positive x-axis. So 180 degree minus this one, and that is going to be tan inverse of height. 1 से लेके 2, height is 1, divided by base. -1 to 1, base is 2. So tan inverse 1/2. Let's see if the calculation required. Calculation last में कर लेंगे. What about phi z2? Okay, what about the phi z2? चलो, let me show you the phi z2 also separately very quickly. Okay, the phi z2, and this is the point which is -1, 2. This is the point which is 1, -1. Okay, let me join this. Let me again construct the triangle. How much is this angle? And again, that is the interior angle. Okay, so that's going to be 180 degree minus of tan inverse how much? तो tan inverse यहाँ पे देखिए 1 से लेके 2. Okay, -1 से लेके 2, the height is 3, tan inverse 3 divided by how much is the base? -1 to 1, base remains to be 2. Okay, this is phi z1 and phi z2. Okay, phi z1 and phi z2. Chalo, Kali also confirms that it is k positive only. Chalo, so this is how much? Okay, let me calculate these numbers, guys. We have, let's do it in degree. Tan inverse half, and then there is tan inverse of. Okay, so degree में नहीं हुआ क्या? Sorry. Let me take it once again. Okay. Okay, this is 277. 277.1 degree approximately. Okay, तो angle of departure कितना आ गया देख लीजिए. 180 degree minus phi p. Phi p is 90. Phi z has turned out to be 277. Approx 277 ही लिख लेते हैं. Okay, so that the total answer should be how much I have. This is 90, and then we have 277. Okay, and then adding with 180 degree. Okay, so it should be 367 तो नहीं लेंगे, principal argument में ले लेंगे, तो it should be 7 degree. Now let's see what is the option. Was it a NAT or MCQ? NAT. Nearest to integer 7. हाँ, Vishal is telling correct. Karuna also telling 7. 7.1. Yeah, that's what. If I take 0.1, वो 7.1 आ जाएगा. Okay, so 367 is equivalent to 7. We know. Always give the answer in the principal range, even if it is NAT. Okay, that's what. मेरे को नहीं पता था NAT MCQ, but पहले ही मैंने बोल दिया 367 should be taken as 7 degree. Give the answer in the principal argument form. All right, you guys also got the answer as 7 degree. Perfect. Let's move ahead to the next question. Okay, so I will not call it as difficult. Of course, this is time taking because calculation of angle of departure बहुत जल्दी तो नहीं होता है, but it's easy one. It's easy one. Okay, guys, another question from signal and system fundamental. Okay, fundamental क्या बोला है? There is a signal, okay, whose energy is given as E. Okay, and there is another signal whose energy, and that signal is 2x, 2t minus 1. Okay, the energy for it is given by CE. What is the value of C? 2x, 2t minus 1. What is the value of the C? Come on, everybody. Right, come on, everybody. Chalo, so देखो, xt का energy है E. Okay. X of t minus 1 as per precedence. Let me start with shifting only, but you can start with the other one also. Okay, time shifting, does it affect the energy? No, energy remains to be E. Okay, now when it comes to x2t, that is time scaling, that definitely affects the energy. Okay, and this is what 2t represents the compression of the signal, and that is why energy also compress. Again, time scaling will not change the amplitude of the signal, but it will halve the duration, and that is why energy also halved. Okay, तो E by 2, but then there is amplitude scaling also. Step by step समझ लिया इसको. तो 2x 2t minus 1. Now if a signal is multiplied by a, energy will be multiplied by a square, because energy is proportional to the square of the amplitude. So this is going to be 2 square is multiplied by E by 2. So the total answer is 2E. Okay, total answer is 2E. So C का value कितना हुआ? 2. That is what you guys are telling. Correct. Karuna, Vithal, Ritik, Grand Masti, correct champions. Done है जी. Okay. चलो. Next question. All right. What is the next question I have? Okay. So there are 3-point charges. So control signal EMFT सारा question जो भी है सामने आ रहा है. There are 3-point charges. Okay. They are Q. Okay. Q, alpha Q. Okay. Q, alpha Q. ये दोनों Q है ना? Q and alpha Q. चलो, perfect. Okay. They are located at. Okay, they are located at -1, 0, 0. Okay, 1, 0, 0. Okay, and 0, -1, 0. Right. So all are 2D. Z coordinate का जरूरत नहीं है. Okay, find the value of alpha for the electric field to be 0. Okay. Find the value of alpha for the electric field to be 0 at 0, 0.5, 0. Okay, तो Z coordinate की तो need ही नहीं है. Let me quickly start by sketching a simple planar diagram here. So what are the coordinates? The coordinates are -1, 0, 1, 0 and 0, -1. Okay, ये लीजिए -1, 0, 1, 0 and 0, 0, यहीं पे देख लेता हूँ. It is 0, -1. Okay, this charge, this is the location -1, 0. This is the location 1, 0. Both of these charges are equal to Q, and then there is the location 0, -1, negative y-axis, where this charge is alpha into Q, जहाँ पे alpha का value निकालना है. Find a value of alpha for the electric field to be 0 at this desired point of observation, जो कि है 0, 0.5. Okay, let us say this is the point of observation. Now we need the electric field 0 at this point. Come on, we need the electric field 0 at this point. Okay. So I think now all gate examinations are completed and students are tired. अब students को solution या किसी चीज में ज्यादा interest नहीं है. आज last slot है. Even other branch students are also now no more interested. Otherwise, they will be curious to know what is happening. Chalo, anyways, guys. Okay. Anyway, so definitely the electric field at the point P. Okay, the electric field will be point P is going to be the vector sum, is going to be superposition, and that's going to be vector sum of E1 plus E2 plus E3. Right? E1 plus E2 plus E3. Okay. अब जहां से देखो E2 तो very simple है. It's in the positive y direction. Okay, the distance can be calculated. Okay, so what's the E2? Let me start with the E2, and E2 is given by K. Okay, where K, as always, I'm taking as 1/4 pi epsilon naught. Nothing is given. The by default free space assume करेंगे. K into alpha Q square. The charge here is alpha Q. The alpha Q square divided by distance. Now, how much is the distance? Okay, देखो ध्यान रखना. If you are taking in terms of unit vector, you can write down KQ, okay, by R square, unit vector along that line. Or the unit vector is also equal to the vector divided by its magnitude. So you can write KQ by RQ vector R. Okay. So the charge here is alpha Q divided by distance here. That is 1.5. That is 1.5 whole cube. And what is the unit vector? चलो यहाँ पे square के form में ही लिख लेते हैं. Because the unit vector is positive y direction. Okay, from the source to the point of observation. ये तो हो गया E2. Okay. Now, when you are going to write down the expression for E1, so see how that is going to be K into Q square. Okay, divided by. Now, how much is this distance? Can we calculate this distance? Pythagoras theorem na, under root of 0.5 square plus 1 square. Okay, 0.5 square plus 1 square is ka under root, and then let me take the cubic form. And what is this vector? Okay, what is the vector connecting these 2 points? Okay, y2 minus y1, so that's going to be 0.5 ay. X वाला लिख लेते हैं. Okay, 0 minus minus 1, so that is simply ax. 0.5 minus 0 is 0.5 ay. Okay, similarly E3 भी लिख लेंगे. Okay, E3 भी लिख लेंगे. This is my third one, so I've assumed this as 1, I've assumed this as 2, I've assumed this one as 3, and that is again going to be kq square, similar distance. Okay, 0.5 square plus 1 square का under root whole cube. Okay, whole cube या whole square, cube वाला formula use कर रहे हैं, sorry. And then the vector. What is the vector here again? Okay, so x component again 1. Okay, and y component minus 0.5. Minus 0.5. Okay, now you are going to add up all these fields. Okay, you are going to add up all the fields. The total electric field at the desired point is the vector sum. Superposition से अगर solve करें, so that's the vector sum of all these. And when you are going to solve it as the vector sum, देखो यहाँ पे dear add किया मैंने, तो already y and y component is going to be subtracted. Okay, okay, but there will be one y component that is going to be left. Rest all this particular component plus 0.5 minus 0.5 ये पूरा cancel हो जाएगा. Okay, so there is only one y component and there is only one x component that is going to be left. Alpha यहाँ पे नहीं आएगा. This is q. Alpha is coming only in the y direction. This is 0.5. 0 minus minus 1 ax, 0 minus 1, ठीक है. ये minus ax है, ये point ay है. ठीक है, तो x component is actually cancelled basically. X component cancel हो गया, so it's only going to be, इसका pointer काम नहीं कर रहा है. Lot of trouble writing going back here and there. तो जब आप add करोगे, it's going to be k. Everything is in y component. Dear, ये समझ में आ गया आपको? The x and minus ax is going to be cancelled. I have alpha square q square. Q square भी common लिख लेते हैं. Okay, so I have the q square also common. Okay, first one से आया alpha square upon 1.5 का square. Okay, alpha square divided by 1.5 का square, and then here kq square common divided by यहाँ पे आ गया है how much? This is the cubic format, and calculations में एक साथ कर लूंगा. चलो calculation लिख देते हैं. Okay, 1.4 approximately. This is coming to be 1.4. Okay, so plus 1 upon 1.4 and 0.5 tha. Again 0.5, 1 upon 1.4. The 0.5 plus 0.5 is 1. Only this much should be left. Only this much should be left, and this is in the y direction. Okay, this is in the ay direction. Okay. So somehow we have to solve this expression and get the value of alpha. The net electric field at this point must be 0. The net electric field at this point is 0. इसको add कर लिया है 0.5, and this is in ay direction. Sir, this was NAT or MCQ? NAT. यहाँ पे डेटा कुछ मैच नहीं हो रहा है क्या? Because alpha square negative नहीं आ सकता ना? This must be minus. यहाँ पे आ रहा है plus.
Maybe some data insufficient in the question.
नहीं, data insufficient नहीं है sir. Data तो पूरा correct है. Taken to be -1. ठीक है, I'll check on to this calculation. Nothing. Okay, ये भी सही है. X component यहाँ पे ax है. अगर first के respect में लिया 0.5 minus 0, 0.5 ay minus ax. X component cancelled होना चाहिए था, वो हो गया 0.5 minus 0, 0.5 ay, and this is also positive ay direction. इसको resolve भी क्या? Everything is in positive ay direction. सब कुछ ऐड हो रहा है, and alpha square can not be negative. Guys, there is some calculation. I'll check on to this calculation. Okay. आंसर तो आ जाएगा न्यूमेरिकली. आई थिंक ये नेगेटिव साइन का डिफरेंस आएगा. चलो, बाय द टाइम लेट मी टेक अनदर क्वेश्चन. चलो सर, मैं कैरी ऑन करूं? यू हैव सम क्वेश्चन? जस्ट one good question I feel. Guys, देखो, x is a discrete random variable. X is given to you as a discrete random variable. Okay, that is uniformly distributed. That is uniformly distributed, okay, over the given set. Uniformly distributed over the set, and that is -10, -9, -8, up to 0, 1, 2, etc., up to the +10. Uniformly distributed. Now, what is the meaning of this uniform distribution? Okay, the uniform distribution basically means that the probability of the occurrence of any of these numbers is going to be identical, is going to be same to 1 upon total number of observation. ठीक है. Question ये पूछा है, okay, which one, 4 options are there, which one, okay, is uniformly distributed? Which one is uniformly distributed? Which one is uniformly distributed? I have the answer as option number A. Okay, that is x minus 5 का square, x cube, x square, x plus 10 का whole square. Correct. MSQ है?
Yeah, hi, sir.
है ना? ये MSQ. This can be MSQ, guys. So we have an MSQ, okay, from the random variable part. चलो. Now, बहुत ही logical question है. It's a good one, but logical in nature. Okay, let's take up the x. Okay, let us start with the x. Okay, the x contains the set -10, -9, -8, 0, 1, up to 10. Now, there is one option. Let me start with x square first. So, dear, when you take the x square, what is going to happen, you know? Okay, you are going to get 0 square. Dekho, -10 and +10 ka square will be converted to one value. So, you will have 0 square, then you will have 1 square, then you will have 2 square. Okay, I mean, agar values likhte jaye, 1, 2 square 4, 3 square 9, up to 100. Okay, up to 100. But is it going to be uniform distribution? Is it going to be uniform distribution? Dekho, if you want to calculate probability of 100 here, probability of 100 is basically because of two events. Probability of x equal to -10 or x equal to 10. X की value -10 या 10 कुछ भी हो, then you're going to get x square as the same value. But what is the probability of 0? 0 एक ही जगह से आया, probability that x equal to 0. So guys, all of these, okay, this is coming from -1 plus 1 square. This is coming from -2 plus 2 square, etc., etc., etc. Okay, so the probability of all these will be double that of the probability of 0. In सबका same होगा, but double that. So overall, it is non-uniform. Overall, it is non-uniform. Hope you have got the idea. Okay, overall, it is non-uniform. Okay, so x square is not going to show the uniform distribution, but at the same time, अब अगर एक logic समझ में आ गया, तो you are also clear with the other options. What's going to be x cube? Now see, when you take the cube, dear, -10 cube and +10 cube will be different. -10 का cube will be -1000. Okay, then you will -9 का cube -729, etc., etc. 0 cube will be 0, 1 cube will be 1, etc., up to 1000. So if I ask you, what is the probability of 1000? It corresponds to probability of x equal to 10. What is the probability of -1000? That is again equal to probability x equal to -10. Each of these events have the probability which is associated with one value of the x, and probability of any value of x is same, क्योंकि x uniform है. X uniform है. ठीक है, तो probability of x equal to -1000 or probability of x equal to 1000, both of them are equal and equal to probability of x equal to 10. Similarly, 0 का probability भी 0 के corresponding होगा, so this is going to be uniform. Yes, this is going to be uniform in nature. Next देख लेते हैं. Now if you have got this, what about the next? x minus 5 का square, x plus 10 का square. x minus 5 का square, x plus 10 का square. x को एक बार फिर से लिखेंगे आपके सामने, so that it's easy explanation. Okay, now if you take x plus 10, if you take plus 10, फिर square भी करता हूं, तो when you take plus 10, you straight away get the value 0. Then -9 plus 10, you get 1. Okay, then you get 2, etc., 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 up to 20. And now you square it up. X plus 10 whole square. Okay, now tell me, all of these numbers, x plus 10, सारे numbers positive हो गए. So when you take the square, each of them will have a unique square. Okay, so this will also be uniform. What is the probability of 20 square? It corresponds to probability x equal to 10. Okay, कोई भी दो x की value नहीं है which will give you the similar outcome here. Why? Because when you take x plus 10, all the outcomes are distinct. All the outcomes are distinct. So when you take the square, it will be distinct. Okay, negative और positive का square same होता है ना? Okay, but here all outcomes are positively distinct. Okay, x plus 10. Okay, ये uniform होगा. And then x minus 5 का square. So x minus 5 का square. Okay, so when you take -5, when you subtract -5, you'll start with -15, -14, 0 -5, -5 hoga. Then in between 0 will come, and then you will go to 4 and you will stop at 5. 10 minus 5 is 5. Okay. But when you take the square, this is only x minus 5. Okay, this is only x minus 5. But when you now take the square, यहाँ पे again overlapping होगा. Okay. -15 का square is 225. Okay, this is going to be 196. ये सब ठीक है. But look into this. 25. 5 square 25. Okay, again 5 square 25. So 25 is coming 2 times, na? 25 is coming 2 times. Okay, the probability that 25 appears here is again associated with 2 events. X equal to -5 or x equal to +5. Okay, and if you take any other case, suppose 225. What is the probability of 225? It is equal to probability x equal to -15. Okay, probability x equal to -15 भी नहीं -10. Okay, x equal to -10. ठीक है. Okay, ये x minus 5 का केस था. Okay, so there x is equal to 0 or 10. X equal to 0 or 10. Again, the idea is two different values of x combine one value. तो यहाँ पे probability ज़्यादा होगा, यहाँ पे probability कम होगा. This is also going to be non-uniform. So which of them is uniform? Which of them is it's a good conceptual question. तो कौन-कौन सा uniform होगा? Okay, the x cube is going to be uniform. Square will not be uniform. X minus 5 square not uniform. X plus 10 का whole square is again uniform. X plus 10 वाला ही solve किया था हमने. Yes, x plus 10 का whole square. This one is again uniform. Right? ठीक है. Utkarsh, even if it is x minus 10, will remain to be uniform. I've got the data x plus 10, so this is the answer. Even if it is x minus 10, ना Utkarsh, मेरे पास शायद x plus 10 आया था. Just a second. Where is that question? I've got x plus 10, but Utkarsh, okay. Even if it is x minus 10, परेशान होने का need नहीं है. If you take -10, then also you have all negative numbers. -20 से 0 होगा. Okay. There is no negative and positive. There is no equal magnitude number. Problem क्या हो रहा है कि if you take suppose -5 or +5 का square, that gives a equal result, ना? But here, even if you take x minus 10, Utkarsh, -20 to 0. Okay, all negative distinct numbers, so none of them will give a common square value. Then also it will be uniform. तब भी वो uniform होगा उत्कर्ष जी. ठीक है जी, डन है, डन है, चलो डन है. Next question की तरफ जाते हैं. Okay, next question. I have one more, and then I think we are ready with the core. Okay, एक और मैथ्स का दिख रहा है यहाँ पे. After that, I'll come back after some time. Okay, what is the sum of eigenvalues of? Sum of the eigenvalues of a matrix A, which is 1, 2, 3, 4 square. 1, 2, 3, 4 square. Square of a matrix given है. Okay. Suppose जो matrix है ना 1, 2, 3, 4. Okay. उसको B matrix बोल देते हैं. Okay. Now, suppose B has the eigenvalue lambda and the matrix A is B square. So that will have the eigenvalue lambda square. That means if the eigenvalue of B are lambda 1 and lambda 2, here the eigenvalues will be lambda 1 square, lambda 2 square. This is one of the very fundamental property. Hope you all know it already. Okay. So now, question क्या पूछा है? Sum of the eigenvalues of A. Okay. Sum of the eigenvalues of A. Lambda 1 square plus lambda 2 square. These are the eigenvalues of A. Okay. Now, very simple. Okay. Solve by identity. Lambda 1 plus lambda 2 whole square minus 2 lambda 1 lambda 2. यहाँ पे ऐसा बिल्कुल नहीं है कि you should be taking the square of the matrix and then calculating the eigenvalue. What you can do is lambda 1 plus lambda 2. Now, lambda 1, lambda 2 are the eigenvalues of the matrix B. Okay. Sum of eigenvalues is equal to trace of the matrix B. Okay. Product of the eigenvalues is equal to determinant of the matrix B. Correct. Trace कितना होगा? 1 plus 4, 5. Okay. Okay, 5. Trace का square है यहाँ पे. Okay, so 5 square. Minus 2 is the determinant. 4 minus 6 minus 2. Okay, so this becomes how much? 29. Check out dear whether it is NAT MCQ. NAT है 29, MCQ है तो जो भी correct option है उसको आप match कर सकते हैं. Right. Answer should be 29 here. Right, guys? Now, sir, you're coming. Which subject, sir?
Machines.
Okay, now guys, Chetan sir is bringing you electrical machines. Score पे भी थोड़ा चले जाते हैं. Chetan sir, Ishan sir, both are ready here.
Yes, sir.
Come on.
So machines के अंदर से one question is asked from the induction machine, that is the 3-phase induction machine that is having frequency is 50 hertz and another data is 6 poles and the speed of the machine is 960 RPM. And in the question, that is one thing is also given, that is the stator copper losses, जो आपके stator copper loss, core loss and rotational losses. means stator core loss and one thing stator copper loss and rotational losses are neglected. Rotational losses are neglected means zero. So efficiency is asked. So how you will calculate the efficiency? So remember one thing, if there is no losses in the stator core loss is zero, stator copper loss is zero, rotational losses is zero, means only one loss is there, that is rotor copper loss. Only one loss is there, rotor copper loss. Because, and remember one thing, always rotor stator loss, जो आपका रोटर का जो कोर लॉस होता है वो तो हमेशा आपका जीरो होता है. रोटर कोर लॉस इज ऑलवेज जीरो. Why? Because it depends on a frequency and the frequency of the rotor is SF. SF. Slip is very less value that contain, it means I think 1%, 2%. So losses are very less. So only this is the loss. So remember one thing, this is the rotor and this is the rotor power input and this is the rotor power output. And you remember that the efficiency is nothing but the output by input, or also N by NS you can directly calculate. So here data is given like this. This is the speed of the rotor directly given. You have to calculate only one thing, NS. N by NS. NS everyone knows. What is the formula of NS? NS formula is 120 F upon P. So for the standard, for the 6-pole machine and 50 hertz, what is the value of NS? 1000. I think everyone knows. So what is the efficiency? 960 divided by 1000 means 96%. It's a very simple question. ये सर फ्री के मार्क्स वाला क्वेश्चन था, मतलब कुछ नहीं करना था यहाँ, सिर्फ देखते ही आंसर आ रहा है.
Okay. Sir, sorry to interrupt you. Okay. So guys, as soon as I entered outside the room, ना, देखो यार क्या guys, आप लोग भी इतना silent क्यों थे? I don't know. I don't even have to check the calculation, guys. As soon as I entered outside the room, okay, कभी-कभी होता है बातें करते करते दिमाग नहीं चलता है. Guys, why are we taking here Q square? Why are we taking Q square here and nobody is even telling me anything like what is this? Why we are taking this Q square? हो गया क्वेश्चन सॉल्व. ये स्क्वायर अल्फा स्क्वायर नेगेटिव आ रहा था ना, स्क्वायर है ही नहीं यहाँ पे. आर यू गेटिंग इट? आई जस्ट स्टेप्ड आउट ऑफ द रूम एंड आई गॉट टू रियलाइज किया दैट इज व्हाट यू नो इज द थिंग वी हैव डन. ओके, सो के क्यू बाय आर स्क्वायर इलेक्ट्रिक फील्ड फॉर्मूला ना. के क्यू देखो यहाँ पे लिखा भी क्यू है दादा. ओके, इट वाज जस्ट अ टाइपो एरर कन्वर्टेड टू अ कैलकुलेशन मिस्टेक. व्हाट आई हैव रिटन हियर, ओके, यहाँ पे क्यू लिखा, यहाँ पे क्यू स्क्वायर कर दिया जबरदस्ती का. ठीक है, सो नाउ लेट मी कम हियर. ओके, नाउ लेट मी कम हियर. सो दिस इज इक्वल टू के क्यू एंड देन इवेंचुअली दिस इज अल्फा. Okay, rest all calculations I'm assuming were true. Okay, so I can take alpha upon 1.5 ka square plus 1 upon 1.4 should be equal to 0. Okay, should be equal to 0, right? So alpha upon 1.5 ka square is equal to minus 1 by 1.4 and hence alpha should be definitely negative of 1.5 square upon 1.4. Now let me tell you what can be the answer here. Approx minus 1.6. Approx minus 1.6. Done है? All right. ठीक है. So alpha is approx minus 1.6. बाकी rest of the calculations you again check it out once. I think calculations में एक आया ही हूँ तो एक बार और retally कर लेते हैं. This is 1.5 perfect तो 1.5 का square. Under root 0.5 square plus 1 square का whole cube. So that's going to be, yeah, that is 1.4. यहाँ पे भी कोई दिक्कत नहीं है. Okay, 0.5 plus 0.5 को मैंने डायरेक्ट 1 ले लिया है. Take you outside, तो 0.5 plus 0.5, 1 upon. Yes, guys. So this is what is the calculation that is resulted in front of me. That is resultant in front of me. Correct है. ठीक है जी. चलो डन है. Sir, you can continue.
नेटवर्क के थोड़ी हुए अभी. नेटवर्क के
नहीं नहीं, network not discussed yet.
ठीक है.
मशीन क्यों कर?
नहीं, कंटिन्यू में करो, आप करोगे. ठीक है, चलो. Now, one question is also asked from the transformer. ठीक है, I don't have the exact circuit diagram, but the transformer के अंदर से जो question आया था वो normal simple सा था कि 4 diagrams of the transformer are given and on every transformer there is a winding. Means only change of the orientation. They change the orientation and in some of the options they maintain the value, like for example in this transformer, if we apply primary voltage या V1 like this is the positive side. अगर positive side यहाँ है तो यहाँ पे जो induced EMF आएगा, this is the induced EMF. E1 की जो polarity होगी, that is just opposite to the V1. Means induced EMF E1 just oppose करेगा V1 को, and the current will flow from this side. Now onward from this point, if E2 is on this point, then V2 is also having the same potential. ओके अगर E2 का पॉजिटिव इस डायरेक्शन के अंदर है तो V2 का पॉजिटिव भी इधर ही आएगा. रिमेंबर ऑल्सो वन थिंग, E2 सेंड्स करंट टुवर्ड्स द V2 एंड ऑल्सो क्लियर वन थिंग. नाउ व्हाट इज प्राइमरी फ्लक्स डायरेक्शन? व्हाट इज द फ्लक्स डायरेक्शन ऑफ द प्राइमरी फ्लक्स फ्लोज फ्रॉम डाउन टू अपवर्ड. so upward flux flow phi1 या phi mutual flux you can say. Now secondary flux, can you just tell me the direction of the secondary flux, upward or downward? So direction of the secondary flux, secondary MMF, secondary flux will flow from upward. So this is the negative coupling or positive coupling. So this is called the negative coupling and it is correct. Negative coupling. I don't have the exact circuit diagrams, but only these are the 4 options. I think ऐसे ही थे कुछ options जो बताए.
Dot polarity थी ना?
Yeah, I don't remember the dot polarity exactly. So basic concept is this. ठीक है. And एक क्वेश्चन आपका मेजरमेंट से भी था, means now there is one option CT and PT and all the 4 options are given. You have to select and options are primary, parallel to grid, and another option is open circuit secondary is not desirable. So can you just tell me which one is correct for the CT and which one is correct for the PT? And one is primary current is the line current, and secondary burden affects the primary current. Okay, so now you can make here like हम इसको ऐसे बोल देते हैं, maybe यहाँ पे A and this is for the B and this is P, Q, R and S. And remember one thing, CT always connects in series with the load like this. Okay, this is the CT and where we put the PT को हम parallel में put करेंगे किसी भी load के या फिर किसी grid के. So primary parallel to grid is for PT. Now open circuit secondary is not desirable. So for the CT, if we open circuit secondary is open circuited, then it can very dangerous. Why? Because CT के अंदर क्या होता है, जैसे करंट लेवल को ये कम करेगा तो वोल्टेज के लेवल को ये काफी ज्यादा बढ़ा देगा. अगर करंट की वैल्यू आपने 0 कर दी, so there means huge voltage will appear across the secondary and it can dangerous to the human that is working nearer to the CT or anything else. So CT के लिए हो जाएगा open circuit. Now primary current is the line current. Primary current is the line current for the CT. And for the PT, secondary burden affects the primary current. So this is the option. These are the options. Now, another question I have is, अगर आपको भी कोई क्वेश्चन पता है तो आप मैसेज कर सकते हैं. Just एक सेकेंड. Yes. So this is the data, 5 kilowatt 220 volt DC shunt motor.
तो बच्चों ये बताओ कि पेपर कैसा गया आप लोगों का? How was the paper? Everybody?
After Chetan sir, I'm going to bring question about power system and power electronics. So session को share करो अपने friends के साथ जल्दी से, and we will solve the question of power system and power electronics together.
Okay. So data is given 5 kilovolt की 220 volt DC shunt motor given with armature resistance with the brushes is equals to the value is 0.5 ohm. एंड नो लोड करंट यहाँ पे गिवन है कि नो लोड करंट आपकी फ्लो कर रही है 3 एम्पियर एंड उस टाइम पे फील्ड करंट 1 एम्पियर है जो कि कांस्टेंट है. इट इज आल्सो मेंशन्ड कांस्टेंट. कोर लॉस रोटेशनल लॉसेस आर कांस्टेंट. सो रिमेंबर कोर लॉस एंड रोटेशनल लॉसेस आर कांस्टेंट थ्रू आउट द लोड. कि जब तक आपका कभी भी लोड चेंज करेगा तो ये कभी चेंज भी नहीं होने वाले. ऑब्वियस सी बात है कि शंट के अंदर फील्ड करंट ये सारे लॉसेस कांस्टेंट ही रहते हैं. सो आपको ये बताना है करंट ड्रॉन बाय द मोटर. जो करंट मशीन ड्रॉ करेगी, जो भी करंट आपकी जो लोड करंट है जो मशीन आपकी ड्रॉ करने वाली है, while delivering rated load for the best possible efficiency means for maximum efficiency. कि मैक्सिमम एफिशिएंसी पे कितनी करंट ये ड्रॉ करेगी. तो क्वेश्चन के लिए आपको डायग्राम ये बनाना था सबसे पहले. Now data is given 0.5 ohm. You can consider it. Okay. And no load current आ रही थी सबसे पहले 3 एम्पियर, 1 एम्पियर इधर चली गई आपकी. And remember one thing. What is the voltage rating? 220 volt. Now अब नो लोड के केस में जो पावर लॉस होता है वो कौन सा वाला होता है? जो नो लोड के केस में पावर लॉस होगा वो कौन सा होगा? कोर लॉस, कॉपर लॉस या फिर कौन सा? रोटेशनल लॉस. तो क्या नो लोड के ऊपर सारे कांस्टेंट लॉसेस कंसीडर किए जाते हैं क्या डीसी मशीन के अंदर? कि यहाँ पे आपके जो कांस्टेंट लॉसेस हैं क्या वो आ जाएंगे? यानी कि 220 इंटू 3 ये कितना हो गया? 660 वॉट. ये क्या है? ये आपका पावर लॉस ही तो है. This is the power loss of the machine at no load. At no load. And remember one thing. There is फील्ड करंट हमेशा कांस्टेंट रहने वाली है. शंट फील्ड वाइंडिंग का रेजिस्टेंस कांस्टेंट रहेगा. तो शंट फील्ड कॉपर लॉस इज ऑलवेज कांस्टेंट एंड आर्मेचर करंट विल वेरी. सो ओनली आर्मेचर कॉपर लॉस विल चेंज. और हियर देयर इज वेरी less value of the armature copper loss. You can calculate 2 square into 0.5 means 4 into 0.5 any 2 watt. Only 2 watt losses are the copper loss. So you can neglect it. Now for the maximum efficiency, what is the condition? For the maximum efficiency, I'm considering just for maximum efficiency, variable loss is equals to constant loss. राइट तो यही होगा. तो यहां जाएगा IA स्क्वायर RA इज इक्वल टू कांस्टेंट लॉसेस आर 660 वॉट. जो कांस्टेंट लॉसेस है, आर्मेचर रेजिस्टेंस की वैल्यू 0.5 पुट करोगे और यहां से एक बार कैलकुलेशन करके निकालना वैल्यू कितना आ रहा है. 660 डिवाइडेड बाय 0.5. तो व्हाट इज द एग्जैक्ट वैल्यू? एक सेकंड कैलकुलेटर. चलिए मैं इसमें सो कैलकुलेट करके एक बार जस्ट वैल्यू बताना. 660 डिवाइडेड बाय 0.5. नाउ फिर इसका अंडर रूट भी लेना है 1320 का आपको. सो आपको अंडर रूट 1320. देयर इज अ कैलकुलेटर गिवन, सो यू कैन जस्ट टेक द अंडर रूट. I think 36 point something value है. 36.33 एम्पियर. It is the value of the current. Means 36 एम्पियर यहां से आएगा. ठीक है. और मशीन कितना ड्रॉ करेगा? दिस इज द आर्मेचर करंट. अगर इसने लोड करंट बोला है तो 1 एम्पियर एक्स्ट्रा ऐड कर देना. कि अगर इसने लोड करंट पूछा है आपसे कि मशीन टोटल कितना करेगा, तो आर्मेचर करंट प्लस शंट फील्ड वाइंडिंग करंट मीन 36.33 में आपको 1 एम्पियर ऐड करना है. सो 37.33 एम्पियर इज द करेक्ट आंसर. ओके ठीक है. चलिए सो अभी मैं एक बार मशीन के क्वेश्चन है, अभी एक बार पावर सिस्टम के ईशान सर डिस्कस करेंगे, फिर मैं एक बार वापस आऊंगा. ठीक है, कुछ और क्वेश्चन आ जाए वो आप हमें भेज सकते हैं टेलीग्राम पे, उसको आगे कंटिन्यू करें।
हेलो एवरीवन, कैसे हो आप लोग? तो पहले ये बताओ कि आप लोगों का पेपर कैसा गया? इट वाज इजी, मॉडरेट, हार्ड, क्या था, डिफिकल्ट लगा आप लोगों को? सो टिल नाउ वी हैव डिस्कस्ड फ्यू क्वेश्चन ओवर मशीन्स। मशीन के ऊपर क्वेश्चन डिस्कस करे चेतन सर ने, देन उससे पहले राकेश सर ने क्वेश्चन डिस्कस करे सिग्नल सिस्टम के ऊपर एंड देन एनालॉग के ऊपर। नाउ वी आर गोइंग टू डिस्कस फ्यू क्वेश्चन बेस्ड ऑन पावर इलेक्ट्रॉनिक्स एंड पावर सिस्टम। नाउ इन दोनों सब्जेक्ट्स की अगर आप बात करो, जो आपका कोर सब्जेक्ट था, ये एक चीज मैंने नोट करी जितने क्वेश्चन देखे कि I have noted one point that power system में there was a two question that was based on a previous year question. If you have done the previous year question, you will observe that particular question, that was exact question that has come. And whereas for a power electronics, the question was directly very simple question. Okay. When you talk about different subjects, I guess like machine and the signals, that are more towards a difficult level. But if you talk about a core subject, so tell me in which question you feel that is difficult. Kiran, tell me in which question you feel कि ये particular subject difficult था. Okay, let's discuss the question here first. Okay, so we have a first question. We have a first question. We will take off. Okay. So we have a power system question. The particular question based on a critical clearing angle. So I'm going to take that particular data of a critical clearing angle and then I will solve it. So wait a sec. Let me check the data. So we have given a particular single line diagram. We have given a particular single line diagram like this, and the fault has been occurred here, and the particular fault has been cleared. The particular fault has been cleared. Now they have given a few data. Let me write down that data first. So they have given before fault. They have given before fault. Before fault, we have power is equal to, I guess, P max sin del. You can also check the data. P max sin del. We have our input power. We have our input power of 0.5 P max. Okay. If there is any problem in data, you can tell me. Then they have said that during fault means when the fault is occurring at that particular power, PE2 is less than 0.5 P max, less than 0.5 P max. And also they have said after fault, the power is actually equal to P max by root 2 sin del. Okay. And they have given a critical clearing angle of pi by 2. And apart from that, they have given one more thing, I guess, or is this a given data? Okay, so this is a given data here. Now they were asking what we need to find out here. We need to find out what is the area of acceleration. Area of acceleration. What is area of acceleration? Equal to x times of P max. So we need to find out this x. Okay. So can anybody tell me what answer you got here? Anybody? Anyone? Tell me, have you solved this question? First of all, have you solved this question? See, to solve this question, you just need to understand the basic. There is no need to remember the whole critical angle formula, or there is no need to remember anything. You just need to understand the basics here. Once you understand the basic, then this question was very much easier side. Okay. Now, from this particular information, can you say what is going to be our particular graph? Let me write down. Let me draw the particular waveform here. So we have electrical power. Now we have first of all this before fault. This was before fault. Okay. And also we have one particular input here. So we have input here which is equal to 0.5 P max. We have input here which is equal to 0.5 P max, or here we have a P max here, right? Apart from that, what we have given, see very carefully, we have given during fault, which is less than 0.5 P max, and then we have after fault, like this, or post fault like this. So this is after fault, and this is during fault. Okay, now bacho, if you have done the stability chapter, then of course you remember this particular diagram, yes or no? This was the one case out of 3 when we discuss about the transient stability, right? So what we need to do here? we have given a particular critical angle, but let's draw the movement of our operating point. So earlier, operating point is at this particular distance, at this particular point, point A. After that, operating point is going towards during fault, and it will remain at a during fault till the fault has been cleared. The fault has been cleared at pi by 2. The fault has been cleared at pi by 2, and then we can go to the after fault equation. And after that, we have this particular thing. And because they are talking about a critical angle, since we have a critical angle, so this is the point at which, at the point C, this is the point at which your particular operating point will go. Okay, after that, it will come back. Now here, what is this angle? What is this angle? Let's suppose this is theta. Let's suppose this is theta. How you can solve this particular angle? Wait a sec. How will you solve this particular angle? You can see the intersection point of before curve and the particular input power. So can you say what is sine theta? Sine theta is equal to 0.5 p max divided by p max. Sine theta is equal to 0.5 p max divided by p max. Yes or no? It comes out to be 30 degree. Any doubt here? This comes out to be 30 degree. Now, if this is 30 degree, so because of the symmetricity here also, we have 150 degree. Here we have 150 degree because they are talking about a critical clearing angle, and in that particular case, the maximum angle will be del max, which is equal to pi minus this particular theta. Remember this point. That's important. No need to remember the critical angle formula. Now they're asking what is the area of acceleration. Now, where does the acceleration happen? The acceleration happened here. The acceleration happened here. But remember one point, when you talk about the critical clearing angle, this particular is a deceleration area. This is deceleration area. So can I say that for stability, acceleration area is equal to deceleration? Why I'm talking about the deceleration area? Because bacho, for the acceleration area, you require P max 2, which we don't know. According to the question, we have given during fault is like this. We don't know what is the actual value or actual curve for the during fault. That's why we will find out the area of deceleration and put it equal to the area of acceleration. This is one method through which you can solve this question through the basic. There is a second method. If you remember the critical angle formula, you can find out the P max 2 and then find out the area. But that particular method is a lengthy method. Okay, so let's solve this particular method. So we can say here, accelerating area is equal to deaccelerating area. Okay, now what is the deaccelerating area? Let's check. So deaccelerating area is between the after fault curve and input curve. This is the deaccelerating area, right? So I can say what is the deaccelerating area? It is equal to particular after fault curve, which is PE3 minus input D del. From where to where? From delta equal to 90, or I can say del 90 to 150. This is the equation you need to solve. Okay, this is the equation you need to solve. Okay, now let's solve this. This is 90 to 150. Now what is PE3? Now what is PE3? It is given in question. It is P max by root 2 sine del. It is given in question. It is P max by root 2 sine del. And if you want, you can separate this integration. It comes out to be 90, 150 degree, and the input power is given 0.5 P max. Easier. Now you have to solve this question and find out the answer. You have to solve this question and find out the answer. So we have P max here. I can say 1 by root 2 integration of sine del is minus cos del from 90 to 150, minus 0.5 multiplied by 150 minus 90. We have this is in degree. We have to convert it into a radian. So it comes out to be pi by 180 degree. Okay. Now let's solve this equation. Tell me guys, anybody solve this question? Yes or no? किसने question solve किया ये? Anybody solve this question? Yes or no? I guess no one has solved this question, huh? We have minus. We can solve here like this. We have minus 0.5 multiplied by We have how much? It is a 60 degree, pi by 3 हो गया वो, ठीक है. Let me solve this quickly. And it comes out to be 0.67. It comes out to be 0.67. Yes or no? It comes out to be 0.67 P max. Okay, so the approximate answer here is 0.67. So this was an NAT type question. If I am not wrong, this is an NAT type question. So the answer comes out to be 0.67. So beta, this to solve this question, there are multiple ways. The first way we have done here. The second way is to go through the formula of critical killing angle, find out P max 2 and solve for that particular question. Okay. Now let's talk about next one. So on one particular question we have on the MOSFET, on particular power electronics, which of the following is the fastest switch? Which of the following is the fastest switch? So we had given a 4 particular option, fastest switch. So we have given 4 options. So I don't remember all the option, but the answer is MOSFET. But the answer is power MOSFET. Basically, they have given the power MOSFET. The answer was power MOSFET, yes or no? We have discussed this many times in our particular classroom that power MOSFET have a high switching speed. That's why it used in your particular inverter, in particular chopper. Okay. So the answer was here is power MOSFET. Okay. This was very simple question. This was very, very simple question, right? Now, again, we have one question based on power electronics. So let me write down that particular question. Now, bacho, if you watch my previous class on this particular channel, last week class, I have discussed one question on buck and boost converter. In that particular class, I told you to remember 3 formulas of boost converter. You can check that particular class last week. And on that particular question, the question has come. Okay, I told you just need to remember 3 formula. Once you remember those 3 formula, you can find out the answer easily. So that was same question that we have discussed in the class. Okay, so let's talk about this. What was the question? So we have given this. If the data is wrong, you can tell me. And it is given plus minus 40 volt. And it is given how much? 10 ohm. It is given inductance equal to 2 millihenry. And we have given inductor current IL. And also we have a voltage of 20 volt. If I'm not wrong, voltage is 20 volt, right? What we need to find? We need to find here IL max. We need to find out here IL max. Okay. Minu, in which questions you feel the exam is lengthy? Tell me, Bacha. In which particular subject you feel the question you feel? Because, okay, that's your perception that exam is lengthy. But on my perception level, if I see as a student, the exam is a more easier to moderate type. And also it's not that much lengthy. In a few questions you have to solve through all the calculation, but also you need to remember a shortcut tricks also, because I told you in a GATE examination you have to solve the question through tricks also. This is correct. There is a more NAT question. That is correct. That's no doubt here. If you feel the NAT question become lengthier, then okay, then the exam is lengthy. Okay, then that's depend on the perception of a person. Okay, now let's solve this question. First of all, you can see this is the boost converter. This is the boost converter. In the last class, I told you about this. You have to remember few formulas here. What is the IL max? IL max is inductor current plus delta IL by 2. Simple. Now for every converter, we have to remember few formulas. So for the boost converter, the average inductor current is equal to I naught divided by 1 minus alpha. I naught divided by 1 minus alpha. So let's find out I naught first. According to a question, we have given voltage is 40, resistance is 10. So it comes out to be 4 ampere. Alpha is equal to, we have a 20 volt here and the output voltage is 40 volt. So obviously alpha is 1 by 2. Alpha is 1 by 2, no doubt here. So what is the inductor current? 4, 1 minus 1 by 2, and it comes out to be 8 ampere. It comes out to be 8 ampere, right? Yes or no? 13 are? Let me check. Answer is 13, Srinath, or the IL is 13. Also, you can check the particular calculation here. So 1, 4 to 8. 8 are na? Right? Now let's talk about the delta IL. Let's talk about the delta IL. It is equal to alpha Vs by FL. So 1 by 2, source voltage is how much? 20. Frequency is given. Let me check the frequency is how much. Frequency is 50 hertz, right? Yeah, 500 hertz. No, frequency is given Can anybody tell me the frequency? Can anybody tell me the frequency? Is it 50 hertz or 500 hertz? Let me take the, let me check. I'm taking 500 hertz. I'm taking 500 hertz, okay? 500. Inductance is 2 into 10 raised to power minus 3, okay? So let's solve it. 5 to 10, 210. हाँ, वो 5 ampere ही होगा. हाँ, 10 ampere. Now put all the values here, all the values in this particular formula. So we got how much? IL max is equal to 8 plus 10 by 2 comes out to be 13 ampere. And bachcho, this type of question we have discussed in the last class. Last class, YouTube पे देखो आप लोग, YouTube पे देखो आप लोग. Last week, I have discussed the same question buck and boost converter. I told you for a chopper, you need to remember 3 formulas, output voltage formulas, then we have a IL max formulas and this. You can solve at almost all the questions asked in a gate examination out of the chopper. Okay, so you can see we had a 2 questions on power electronics. One, they were asking the fastest switch. That was easier. This question is also very much easier, right? Yes or no? Now let's talk about the next question. Let me check if I have one more question. If you have more questions, you can also tell me. If you have more question, bacha, you can also tell me. Meanwhile, let me check it. Okay. Now, tell me, there was one question based on electrical circuits, that how many junctions we have. You remember the question? Okay. Now, there was one question in a power system. Let me write down that particular data. If there's any confusion in data, you can ask, okay? Or you can tell me in a comment section, okay? I'm going to write down force commutation का भी अभी लेता हूँ. First, I'm taking one question of power system. If you remember a data, you can correct me. So we have given 3 buses. That was bus number 3, bus number 1, bus number 2. We have given this P1, we have given P1, we have given P2, and we have given P1 is M times of P2, right? They are connected via transmission lines. And it is J alpha X, J beta X, and it was J gamma X. And the question is X is greater than 0. We need to find out a relation between alpha, beta, and gamma. If I'm not wrong, this was the question. And one thing also given that angles are very small. It is given. Angles are small. And also one thing was given that the power transfer between P1 and P2 is 0. Power transfer between P1 to is 0. Okay, this was given. Okay, so tell me, this was the data was given, yes or no? Okay, I'm confused in alpha, beta, gamma. So if there's any doubt in this particular data, you can give me. Okay, so tell me guys, जो बच्चे online है exam कराए, जल्दी से बताओ. Is the data is correct? Because we need to find out a relation here. Okay, so let's see. So first of all, how to solve this question? Now this question, if you see the previous year question from a power system, I forget the year, but if you see the previous year question, one question has been asked exactly like this. In that particular question, numerical values were given. Here they have given you the variable and finding out a relation. Okay, but the question was exactly like this, beta. That's why previous year questions are very important. Okay, so let's solve how to solve this question. So we have given that P12 is equal to 0, means power transfer between the bus 1 and bus 2 is 0. So if power transfer between bus 1 and bus 2 is 0, it means the power given by the P1 is going towards the bus number 3 and the power given by the bus 2 is going towards the bus 3. There is no power transfer taking place between them. Okay. So now what we can write down, what we can say that how much power is transferred between P13. Now P13 is equal to V1 V2 by V1 V3 by X sine delta 13. Now one more information was given here that the voltage at every bus was equal to 1. Magnitude of voltage at every bus was equal to 1. It was given. Okay, so P13 is given how much? It is given P1 is m times of P2. So I can say m times of P2, n times of P2 here. Is there any doubt here? Is there any doubt here? Tell me in this particular question. So V1, V3 is 1. Reactance between them is beta x. Beta x sine del 1,3 sine del 1,3 is equal to m times of P2. It is given. I'm guessing this particular question is given. If there's any problem in data, you can tell me. Apart from this, you can also say apart from this, you can also say, since there is no power transfer between 1 and 2, the bus number 2 is giving power to bus number 3. So I can also say it is equal to m 1 by it is gamma x. It is gamma x 1 by gamma x sine delta 2,3. Sine delta 2,3. Now, according to question, the angles were very small. The angles were very small, so you can cancel out the angle here. You can cancel out the angle here. You will left with 1 upon beta x, 1 upon beta x, m upon gamma x, x cancel out again. So gamma comes out to be m times of beta. So if this is the particular information is given, then the answer was gamma is equal to m times of beta. So tell me, have you solved this question, guys? Yes or no? And मैं देख रहा हूँ बच्चे सेशन से जा रहे हो. शेयर करो सेशंस को अपने फ्रेंड्स के साथ. आपको आंसर्स मिलेंगे टाइमली. यू विल गेट द आंसर्स हियर एंड एवरीथिंग. राइट? बताओ बच्चों, कोई डाउट है इसके अंदर? Any doubt in this question? Now there was a one question someone said about forced commutation. So if you have a question, you can send the question basically on our Telegram channel also. We can pick the questions from here. Okay? Tell me, anyone else? Anyone else? Okay, so let me take one question more about the forced commutation. Few students are saying, so if the data is correct, let me check. So we had this particular question. And we have auxiliary thyristor, and this is the, this is the main thyristor. It was the auxiliary thyristor. Capacitor has been charged to some voltage, and we have given a load here. And we have given some source voltage here. Okay. Now tell me the voltage here. What is the voltage here across the capacitor? Do you remember the voltage across the capacitor? Yes or no? Do you have remember? So what they've asked here, they have asked you what is the turn off time here. Basically, they have asked you what is the turn off time here once the auxiliary thyristor is on. Now see very carefully here. There was one particular load current also, I naught. So once you turn on the auxiliary thyristor, what will happen? What will happen? The current will start to flow in this direction. And there is one more current goes in this direction. The current will start to flow this direction. But what will happen? Because of the reverse polarity across the capacitor, the main thyristor will switch off. Or you can say there will be a reverse voltage across the capacitor. But expected cutoff around 25, 27. I guess it may change, but for a general category student, it will again around 25 to 27 out of this. Okay, 50 volt. Okay. 50 volt is saying one of the students, so we can check it. And there is a capacitance value given. So what will happen here? As soon as you turn on the switch, the auxiliary thyristor, the main thyristor will be off. Here, है ना? Main thyristor बंद हो जाएगा आपका. The main thyristor will be off because of the reverse voltage applied across it. Now they were asking, what is the turn off time of an auxiliary thyristor? So बताओ, anybody has solved this question? Tell me, anybody else solve this question? Tell me, bachcho. Let me check if the data is correct. IL is 10. If I'm not wrong, IL is 10, no? IL is 10, huh? So I have got the data. IL is 10. It is a 50 volt. It is also 50 volt. So in the question, it was mentioned capacitor was charged to 50 volt, and they're asking what is the main thyristor turn off time. Okay, main thyristor turn off time. Now turn off time, or you can say, is the time for which the thyristor remain reverse biased. a turn-off time is the time for which that thyristor remains reverse biased. This particular line you know. So at soon as you turn on the particular auxiliary thyristor on, this particular thyristor will get the reverse biased and the capacitor will start to discharge. Now, if a capacitor is start to discharge, so can I say capacitor voltage will be like this? Capacitor voltage will be like this. It is start to discharge from minus 50 to 50 volt. Why? Because it is the source voltage given. Because it is the source voltage is given. Now, the particular main thyristor is going to be reverse biased for this particular interval. The main thyristor is going to be reverse biased for this particular interval, and you need to find out this particular time. You need to find out this particular time. So it is very, very simple question. But how you can get this question wrong? If anybody had got the wrong answer, it was very easy question. Very, very easy question, right? How? Simple. So capacitor current is equal to C dV by dt. This is the capacitor current formula. Now from here, I can say the capacitor current is equal to load current, because as soon as the main thyristor is off, the load current and capacitor current will be same. So it will be I naught C, change in voltage is 50 volt, and we need to find out the turn off time. So T off comes out to be capacitance. Capacitance पता है कितना दिया हुआ है? Do you remember the capacitance? 10 microfarad. 10 microfarad. Okay. One student has said 10 microfarad. Okay. 10 into 10 is to power minus 6 multiplied by 50 divided by 10. So 50 microsecond. Data according to this data, the answer is 50 microsecond. According to this data, the answer is 50 microsecond. Right? According to this data, the answer is 50 microsecond. They have given that I naught is this, and they have given capacitance is 10 microfarad. Okay. So Kalicharan, yes, you have given the right answer. Okay. Now tell me guys, there was one question based on thyristor that I think you can say that was a moderate question. Otherwise, we have discussed 3 questions of power electronics. All these 3 questions are simple. All these 3 questions are simple. Okay. There was a one question that has been asked from a power electronics subject in which you have to use the drive formula. And you have discussed about the key. We have a single phase rectifier. We had a single phase rectifier, and we need to find out what was the firing pulse for the regenerative braking. I don't have that particular data right now, but soon the data will come. I will discuss the question with you. But that was very much simple. You need to find out the output voltage, and once you have an output voltage here, you should use the formula of 2 Vm by pi cos alpha, which is the single phase formula, right? So that question we will discuss once we have a data here. Now let's see. Now let's see what we have. Wait a sec. Is there any more question? If there's a more question on power system and power electronics, you can discuss. Okay. Meanwhile, just after me, AC voltage controller question was asked. So I guess they were asking what is the ACG and AVG, automatic voltage generator and automatic voltage controller. Yes or no? Tell me if I'm correct, because one of the students has called me and asked me that particular question. If I'm correct, yes or no? So anybody solve that question? Yes or no? Anybody solve that particular question? Let me check one more question. Just give me one few seconds. Achha, I got one more question of power system. Let me discuss that question first. Then I will discuss AC voltage controller. Okay, one more question. So they have given 4 buses. They have given 4 buses here. 1, 2. Now, this was also the previous year question. If you remember. Tell me guys, who remember that this is a previous year question? One of the YouTube class I have discussed this question. Because it was very easier. It was very much easier. So we have I here. We have a I here. We have a I here. And I guess the generator is connected here. If I'm not wrong, you can tell me. And we have given this is a branch 1. This was a branch 1. This was a branch 2. This was a branch 3. This was a branch 4. This is given. And we have also given that branch 1 is 4Z, branch 2 is Z, branch 3 is 2 times of Z, and branch 4 is 4 times of Z. If there any problem in data, you can tell me. If I'm not wrong, this was the data, right? Right, Bacho? This was the data, Shinat. Now we have to find out we need to find out which branch we need to remove so that the power loss will be minimum. है ना? The question was which branch we can remove so that power loss is minimum. So that power loss is minimum. And bacho, I'm telling you, the same question has been asked in the previous year. In that particular question, they have given the same reactance everywhere, but here they have given the reactance, or I can say the impedance. They have given impedance in this manner: 4Z, Z, 2Z, and 4Z. Now, how you can solve this question? You have to remove each branch and you have to calculate what is the power loss there. And whichever case we have a minimum power loss, that will be the answer. Same, right? So let's do this question one by one. Let's do this question one by one. So I'm going to remove branch B1. So remove B1. Remove B1. If you remove the B1, the particular network, or you can say the single line diagram, will be like this. This is I, this is I, this is I, and we have Z, 2Z, 4Z. Okay, we have Z, 2Z, 4Z. Now, see very carefully here. When you remove the branch B1 here, how much current will come from here? The current will be 2 times of I, so that the current I will leave here and the remaining current I will enter here. Is this correct, or there's some wrong in the data? Let me check. 2 times of I. Okay, fine. This is 3 times of I. My fault. 3 times of I. This is 2 times of I, and here we have I here. Okay, this was the data. Yes or no? Tell me guys. अगर आपको क्वेश्चन याद है तो मुझे बताओ. Data ये था. एक बार मैं चेक कर लेता हूँ. Let me check it once. कि whether we have correct data or not. I guess the data is this one. Okay. Now what is the power loss formula? Power loss formula is equal to I square multiplied by R. Now you have to calculate the power loss in each and every branch here. This is branch B2. This is branch B4. This was branch B3. So let's calculate here. Now we have given impedance Z. Z means the resistance is R. Okay. So the power loss will be here. In this particular case will be I square. It means 9 I square multiplied by R plus, for this branch we have 2I current. So it will be 4 I square multiplied by 4 times of R. Why 4 times of R? Because we have 4Z. So 4R. Then we have a 2Z of current I. So we have I square multiplied by R. So we got 16, 9 plus 1, 10, and 26. So if I'm not wrong, it is 26 I square R. It is 26 I square R. So for the branch B1, we have 26 I square R, which I feel is a very large number. Let's check for another one. Okay, so B3 and B4 has given the answer. Let's calculate for B3. So I'm removing B3. Remove B3. So if the B3 is removed, the B3 कौन सा वाला है? Let me see. B3 कौन सा वाला है? ये वाला. Okay. So once I remove the B3, the network is like this. Okay. So this is I. Okay. So what will happen here? This will be 2 times of I, and then I will be here. This is only I. So let's calculate power loss. So it is I square. Multiply resistance कितना दिया यहाँ पे? Of this particular branch, resistance given is Z. Okay, Z 4Z 2Z. Okay, so Z 4Z 2Z. So I square multiplied by R plus for this I square multiplied by 4R plus for this कितना दिया? Forget again. So we have given 2Z. Okay, so I square 2Z. नहीं, we have that particular branch now. So B1 is given 4Z. So 4 plus 4 plus 4, 12 I square R. So for the branch B3, we have 12 I square R. Varun, sir, will you solve the network question of ECE? But for ECE, the session is already done in a morning session. That was ECE. We are talking about the electrical session here. Okay. So see here very carefully. So the answer is not B4, B1. The answer is not B1. The answer is not B1. Either it is B3, B2 or B4. Now let's calculate for B4 also. Let's calculate for B4 also. So if I remove B4, so B4 कौन सा वाला है यहाँ पे? B4 is this one. Oh, okay, B4 is this one. So if I remove B4, we have I here, we have I here. Now let's calculate. This is 2 times of I, this is I, this is also I. Now let's calculate the power loss here. So it is 2I whole square multiplied by 2I whole square multiplied by 4 multiplied by 4R. For this, it is I square multiplied by 2, I square multiplied by 2R. Plus for this branch, we have I square multiplied by which branch? B2 है ना, तो Z हो गया. I square multiplied by R. So 4 plus 2, 6 plus 7. 7 I square आ रहा है. Calculate it. 7 I square आ रहा है. Yes or no? Sonali, can you tell me which questions or which subject you feel that it was a tough paper? So I guess Kiran has given a right answer, B4, because we are getting 7I square R. But let me check the calculation also. And the data is this one. If the particular data is changed, the answer will be different. Okay. So we have B1 4, B2 Z, B3 2, B4 4. Okay. Now we have removed the B4. So we got 4I multiplied by 4. We have given 2I square. So 4 multiplied by 4. Achha, my mistake. 16, 18, 19. 19 हो गया यहाँ पे. 4 4 the 16 plus 2 18 plus 19. No. B4 is not the answer. So the answer given by Srinath is correct. The answer is B3. You can also check from B2. Okay. Any doubt here? Okay. So these are the few questions that we have discussed based on power system and power electronics. And now we will solve question based on the network theory. The Sanjay sir will take that particular class. So let's wait for few minutes. Okay. So Sanjay sir भी आ गए.
चलो
Sanjay
ओके
sir is
गाइस,
going to continue class.
निशान सर कैसा रहा आपका पावर इलेक्ट्रॉनिक्स एंड अदर सब्जेक्ट्स?
सर पावर इलेक्ट्रॉनिक्स तो इजी था. पावर सिस्टम में बच्चों को थोड़ी मुश्किल लगी. ऑल्दो क्वेश्चन वाज 2 क्वेश्चंस फॉर लाइक फ्रॉम अ प्रीवियस ईयर क्वेश्चन. वहीं से डेटा चेंज करके क्वेश्चन पिक करके दे दिया पावर सिस्टम में.
बढ़िया सर.
बट से सर अब आप नेटवर्क्स ले रहे हो?
हाँ, नेटवर्क्स एंड थोड़ा एक आध क्वेश्चन एनालॉग के करवाता हूँ मैं.
ओके
गाइस, तो देखो ये नेटवर्क में ना एक तो बहुत इजी क्वेश्चन आया था. अब आप ही बताएंगे 1 मार्क्स है या 2 मार्क्स. यहाँ पर आपसे पूछा था व्हाट इज द पावर डिलीवर्ड बाय द 10 वोल्ट बैटरी, और आंसर इज 50 वॉट, 100 वॉट, 0 डिपेंड अपॉन द अल्फा. यहाँ आप चाहते तो सिंपल सा कैलकुलेशन कर सकते हो. आंसर क्या है भाई? अपने कमेंट बॉक्स में आंसर दीजिए. क्या है आंसर? व्हाट इज द आंसर फॉर दिस क्वेश्चन? देखो सिंपल सा, यहाँ देखे ये हो गया ए पॉइंट, ये हो गया बी पॉइंट, राइट. इसको कट करो यहाँ से, और देखो जो रजिस्टर दैट व्हाट 2 ohm रजिस्टर, नो नीड टू कंसीडर द 2 ohm रजिस्टर बिकॉज इट इज इन सीरीज विद व्हाट 10 एम्पियर. देन यू कैन कन्वर्ट दिस 1 ohm and 10 ampere into what? A voltage source. When we are converting it into a voltage source, this is the alpha, right? This is the A point, this is the B point. No need to consider this 2 ohm because it is in series, because same current will enter here 10 ampere. Then 10 multiplied with the 1, it will give 10 volt. This is the 10 volt, this is the 1 ohm. Now guys, watch this diagram. This is alpha. This is the 10 volt, this is the 10 volt. So what is the current given by this battery? 0. Current given by this battery is 0. 10 minus 10 upon 1 plus alpha, that is 0. And that's why the power delivered by this battery is 0. Answer is 0. It depends upon alpha, no. And directly some students will give the answer depends upon the alpha, but that is not the correct answer. So I think now it is clear to you. This was the first question. So how many students have given the answer? 0. 0 for this. चलिए अब आते हैं नेक्स्ट क्वेश्चन में विदाउट एनी डिले. अच्छा भाई जल्दी से आप अपने फ्रेंड्स को बुला लीजिए कि चलो क्वेश्चंस डिस्कस करते हैं. ओके देन नेक्स्ट वन. एक मिनट आपके कमेंट्स में देख लूं जरा क्या है. यस सर 0 ना. नाउ सेकंड क्वेश्चन, सेकंड वन. अब आते हैं सेकंड क्वेश्चन में. तो सभी ने 0 दिया है. कितने लोगों ने 0 दिया है भाई? Now, next one is this one. Right, find the time constant after the switch is closed. यहाँ पे दो कंफ्यूजन हो सकता है आपको कि सर करंट सोर्स का क्या करना है। मैं आपको दोनों मेथड बता देता हूँ कैसे सॉल्व करना है इसको। ओके, अब देखो यहाँ क्या करना था, इस पॉइंट पर this is the 1 Henry 1 ohm 1 ohm 1 Henry 1 Henry. That is a one simple way is what time constant after the switch is closed. तो टाइम कांस्टेंट निकालने के लिए कितना है आप लोगों का टाइम कांस्टेंट, जरा आंसर दीजिएगा। देखिए फर्स्ट ऑफ ऑल आप सीधा लगा सकते थे टाउ इज इक्वल टू व्हाट, एल इक्विवेलेंट बाई एल बाई आर, एल इक्विवेलेंट बाई आर इक्विवेलेंट। तो जो भी एक्टिव सोर्स है ना, फर्स्ट ऑफ ऑल मेक इट व्हाट, ओपन सर्किट। व्हेन वी आर मेकिंग इट ओपन सर्किट, now this switch is closed now. When the switch is closed, you can watch, this is the resistor, this is the inductor, and this parallel combination, just like a resistor, it will become 0.5. This is 1, right, and this is 1. Okay, this is resistor. Now these two resistors, 1 and 1, that will become 2, and then total inductor will become what is in series, 1, 1.5, 2.5. Right, now you can directly say, sir, what is the time constant of that? This is the 2, so L by R, 2.5 by 2, 2.5 by 2, that is 1.25. Okay, 1.25. तो कितने लोगों का आंसर आया 1.25? बहुत यस आया ये भी आंसर, दैट यू आर गेटिंग द 1.25. नाउ समटाइम ना डाउट आ जाता है कि सर ये राइट है या रॉन्ग है इन एग्जाम हॉल. तो सम स्टूडेंट्स आई थिंक यू हैव सॉल्व लाइक दिस. फॉर एग्जांपल, let this switch is closed, guys. When this switch is closed, let this current, these inductors are in series parallel, so that's why you can replace this by what, 0.5. You can replace this by 0.5. Now this is the 0.5 and this is 1 and 1.5. So you can also replace this 1.5 now. Okay, so that is the gone here 1.5. 1.5 Henry. Now watch this. This is 1 ampere. Let this current is I1. So what is the current here? 1 minus I1. Suppose you want to calculate the time constant. That is, there is another way to find the time constant. One way, L equivalent of R equivalent. Second way, I1, 1 minus I1. That current will become 1 minus I1. Now, what is the voltage at this point V? From this point to this point and from this point to this point, voltage is same because it is a reference. So what is the voltage from this point to this point? You can write V is equal to I1 into 1, that is the R. So I1 into 1 plus what is the voltage across the inductor? L di by dt. So di1 by dt. Okay, you can write similarly from this point to this point, you can write V is equal to 1 minus I1 into 1. That is the current, 1 minus I1 into 1 plus L. What is the L? 1 di1 by dt. D by dt of what is the current here? 1 minus I1. Now write this. V is equal to 1 minus I1 plus what is the differentiation of constant? 0, and that's why it will become minus di1 by dt. Okay, now you can equate these two because that is the same thing. I'm giving you the another method. So I1 plus 1.5 di1 by dt is equal to, that is what 1 minus I1 minus di1 by dt. Right? अब इसको यहाँ शिफ्ट कीजिए, देन यू विल गेट द 2 टाइम्स ऑफ I1 प्लस 2.5 टाइम्स ऑफ di1 by dt is equal to 1. You are getting the differential equation. I di1 by dt plus what is this? You can divide it by the 2.5. That will become 2 divided by 2.5. I1 is equal to what? 1 upon 2.5. 1 upon 2.5. So you will get this differential equation, non-homogeneous differential equation. So for transient, this is the 2 divided by 2.5 is equal to 0. And you will get the root, that is a transient equation. I1 is equal to k times of e raised to power minus, right? That is the root. What is the d is equal to minus 2 by 2.5 into t. Now you can compare with what? E raised to power minus t by tau. So what is the time constant from this? 2.5 by 2. So you can verify, but that easy method is what? The first one is the easy method, but some students got confusion. Sir, how to find that? So directly you can get the differential equation. Again, you will get that is the tau. What is the tau? 2.5 by 2. Tau is the 2.5 by, and that is the transient part. That is not the complete solution. This is only the transient part. तो by using the differential equation. Now similarly, तो कितने लोगों का आया है भाई आंसर? Yes, please give me comments. अब आते हैं नेक्स्ट क्वेश्चन पर. Next one is this is the time constant. Now this is the question on diode. What is the current through the diode D1? So there are two diodes, guys. There are two diodes. So what was the answer for this question? What is the answer for this question? Now this is the diode D1, that is the diode D2. For D1, what about the position? There are four cases, D1 and D2, both off, on, off, or finally both on, right? So no need to check all the condition. No need to check all the condition, guys, in this question. How we can solve then? Simply, first of all, watch this. Suppose you are assuming that both the diodes are off. That is not practically possible. If both the diodes are off, this what is the current through this 1 kilo ohm? 0. This will become 0. That is the 3. This is 0. That is the 3, means that diode is on. And similarly, this is 5. So first option is not possible. Second, let we are saying that D1 is off, D2 is on. When the D1 is off, means there is no current. Now D2 is off, on. So what we can do, we can convert it into a Thevenin's equivalent. That is the, what is the drop at this point? Thevenin's at this point. You can cut. What is the voltage at this point? 2.5, and 1 kilo ohm and 1 kilo ohm are in parallel. So simply you can convert like this. This is the 2.5, 1 parallel with 1 parallel with 1.5, and that is 5 divided by 2, that is the 2.5. This is called Thevenin's across this point. Then diode is connected here. This is the resistor, and then this diode. Now this is the 3, and this is the 1 kilo ohm. Okay, and that is also 1 kilo ohm. Now, if suppose you are assuming that this diode is off, and you can say directly current is 0. But what is the current in this case when this diode is on? When this diode is on, you can directly find the current. 2.5 divided by what? 1 plus 1 plus 0.5, 2.5 divided by 2.5. Then what will be the current? 1 milliampere. 2.5 divided by this one, 1.5, that is the 2.5, that is 1 milliampere. If it is 1 milliampere, what is the voltage at this point? 1 into 1 volt. On positive side, it is 3 volt. On negative side, it is 1 volt. Means what? That diode is on. And our assumptions is what? Wrong. Our assumptions is wrong. Now, next assumptions is what? That is, you can say, sir, if suppose it is proved that it is a 5 volt, and that's why there is a positive current. So next assumptions, what we are assuming that this diode is on as well as this diode is on. Both are on, final condition. When I am assuming the final condition, both the diodes are on, guys, then what will happen? This is wrong. Our assumptions is wrong. Now, if both the diodes are on, so what is the voltage at this point? It will become 3 volt. Already I have given you the Thevenin's equivalent, that is the 0.5. This is 0.5. This is 2.5. 0.5 and 2.5. This diode is on. That's why it will act as short circuit D2. And now this is the 1 kilo ohm. And this is the battery of 3 volt. It is directly connected here because this diode will act as short circuit. Now we have to find this I. Okay, so this is the 3 volt. Now, at this point, this is I1. This is I. You can apply the KCL at this point, guys, and to find the I. So what is the incoming current I1? What is the I, and what is the current outgoing current like IX? So you can say IX is equal to what? I1 plus I. I1 plus I. So what is the I is equal to IX minus I1. Simple. So IX is equal to 3 by 1, 3 minus 2.5 minus that value, right? And divided by that 0.5. So you will get this answer. Okay, 1 minute. This is the 1 kilo ohm resistor. This is also a 1 kilo ohm resistor. Otherwise, you will get the negative current. Now, 2.5, then value, and then what? We can find the current, guys. So in this case, okay, 1 minute. Everything is fine now. So what is the value of the battery? 1 minute. I think this is the 10 volt. No?
Could you try again?
1 minute, 1 minute, 1 minute. That value is, I think, 10 volt. No? वहां पर वैल्यू कितनी है मैं आपको बता दूं जरा। वैल्यू ऑफ द बैटरी इज 10 वोल्ट। वन मिनट। दिस बैटरी इज ऑफ 10 वोल्ट गाइस। ओके चलिए कोई बात नहीं, कैलकुलेशन में ये वाली जो बैटरी है ना ये 10 वोल्ट है, मेथड वही रहेगा। दिस इज द 10 वोल्ट, when this is the 10 volt, so now in last question that will become 5 volt। तो थेवेनिन्स लगाना है और ये हो गया आपका इजी 5 वोल्ट। ओके अब देखो यही सेम चीज यहां आ गया 5 माइनस 3 अपॉन 1.5 दैट इज द वैल्यू। दिस इज द 3/1 एंड माइनस I1 5 माइनस 3 upon what 1.5। okay now you can calculate this value। this is the 2/1.5 or that is you can write minus 4/3। okay and now you can find the value guys। so 5/3 is the answer for this question। 5/3 तो इसको करेक्ट कर लेना कैलकुलेशन। ये है 10 वोल्ट एक्चुअली 10 वोल्ट के हिसाब से। दिस डायोड इज ऑन, दिस डायोड इज ऑल्सो ऑन एंड द करंट थ्रू दिस इज 5/3 एम्पियर, मिली एम्पियर नॉट एम्पियर, मिली एम्पियर। तो कितने लोगों ने ये क्वेश्चन सॉल्व कर लिया भाई, है ना। देखो यही अगर आपने अगर थोड़ा सा भी डेटा अगर गलत लिख दिया तो आंसर गलत आ जाएगा। तो वहां पर तो एग्जाम में आप में भी गलत। सर वंस चेक अल्फा क्वेश्चन बिफोर व्हाई they asked power across the 10 volt। अच्छा लास्ट क्वेश्चन दैट इज पावर डिलीवर्ड बाय द 10 वोल्ट ना, दैट वाज द क्वेश्चन। और पावर अक्रॉस, तो पावर गिवन बाय द 10 वोल्ट बैटरी दैट व्हाट इज द पावर अक्रॉस और पावर गिवन बाय द 10 वोल्ट बैटरी दैट इज 0। इज देयर इज एनी अदर प्रॉब्लम? क्या है आपका कमेंट्स क्या है भाई जरा बताओ। अराउंड 30। सर वंस चेक द अल्फा क्वेश्चन बिफोर, क्या हुआ बताइए उसमें क्या प्रॉब्लम है। ये वाला क्लियर है? यहाँ पे थोड़ा सा करेक्शन कर लेना, ये भी जो थेवेनिन्स आपने निकाला है ना ये वाला ये भी 5 आएगा क्योंकि ये बैटरी की वैल्यू जो है ना वो 10 वोल्ट है। बैटरी की जो वैल्यू है दिस इज द 10 वोल्ट। तो मैंने तो सिंपल ये मेथड से किया है, ये थेवेनिन्स लगा दो बहुत ज्यादा इजी हो जाता है। ओके अब जैसे आप बोलोगे सर ये भी तो हो गया, अब करंट तो बढ़ गया यहाँ पर तो भी कोई बात नहीं, तो अब भी वेरीफाई हो जाएगा। दिस इज द 5 वोल्ट राइट। नाउ व्हाट इज द करंट हियर, 5 divided by 2.5। तो 5 divided by 2.5 that will become what 2 milliampere। so 2 into 1 what is the voltage at this point, it will become 2 volt। it will become 2 volt। on the positive side it is 3 volt, on the negative side it is 2 volt। that diode is not off and our assumptions is wrong, this is not off। so both are on and the current is what 5/3 milliampere। is it clear? okay then तो 5/3 तो दैट इज द आंसर। तो कितने लोगों का आया है 5/3? हाउ मेनी स्टूडेंट्स गॉट द 5/3? नेक्स्ट क्वेश्चन इज व्हाट दैट इज ऑन व्हाट डॉट कन्वेंशन। हाउ मेनी स्टूडेंट्स you have solved? this is a very lengthy question but it is a very tricky one। tricky one means what, first of all that question is given omega is given as 5000 radian per second। omega for this question is given as 5000 radian per second। okay and some extra component is given here something and so on। but what is asked, what is the Z equivalent across P and Q? what is the Z equivalent across P and Q means up to this point we have to find। so guys first of all you have to find what J omega L1। so what is the J omega L1? J 500 L1 is given as 125 millihenry। 125 millihenry, so you can find say J 625 ohm। J omega L2 is given as 1 millihenry and that's why it is a J 5 ohm। then J omega M 5 millihenry, that is given in the question, so you can find J 25 ohm। and now minus J by omega C means that is the value minus J4 ohm। once it is known then you can convert it into what frequency domain। so we have to convert this diagram into what frequency domain, then you can solve। then guys now this is the diagram, First of all, replace this, right? That is what? Minus J4. Now replace this inductor, and so on. Now, what is the value? J, right? J omega L2, J5, J625. J5 ohm, J625 ohm, and this is the J omega M, that is what? 25. Okay. Now, you have to make a equivalent diagram, remove the dot. So, how we can remove the dot here? Watch this. This is the 4 ohm. This is 4. Now, this is 2. You have to draw the equivalent circuit like this. Now, this is replaced by J625. Here it is. Again, one dependent source. And this is the capacitor here. Minus J4. And this is what? J5. Now, what is this? J omega M. This is the J omega M. So, this is the J omega M, J25 into I1. I am assuming that this current is I1. This current is like I. That voltage at this point is V across the PQ, and that is the I. And that is what? 4 ohm. This is 4 ohm. This is 2 ohm. Now, this is J5. This will become J25 I1, and I am assuming that this current is I2. So, that will become J25, J omega M I2. Now, polarity, dot convention. This current will leave the dot. This current will leave the dot. And this current will enter into the dot. When this current will leave the dot, what is the polarity? This dot will become minus, this will become plus. Since this I1 enter into the dot, that's why this will become plus, that is the minus. Now, question over. Guys, what we have to do? First of all, write down the KVL at this point. When I am writing the KVL, J5 minus J4, it will become JI2 or J25 I1 minus J25 times of I1 minus, this will become plus J times of I2. J times of I2, guys. So, this is the minus J25 times of I1 plus, this is minus, and that is plus J times of I2 is equal to 0. So, from this you will get I2 is equal to 25 times of I1. This is the first one. Second, quickly you can write a KVL here. So, when I am writing the KVL here, it will become 2 plus J625, right? Now, inspection method you have to use. When I am going to use the inspection method, it will become what? We have to find a V by I. We have to find a V by I here. So, first of all, I am writing the equation, inspection method. It will become 4 plus 4, 8I minus 4 times of I1. This is the second equation. Minus 4 times of I1, that is the mesh analysis. Now, here I am going to write 0 is equal to 4 plus 2, 6, plus J 625. And now, into what? I1. Then, minus J 25 times of I2. And then, finally, this is what? Minus 4I. Minus 4I is equal to that 0. Now, you can replace this what? 25 times of I1. The 0 is equal to 6 times of I1 plus J 625 times of I1 minus J 625 times of I1 minus 4I. So, this is cancel out. From this, you will get I1 is equal to 4 by 6 times of I. That is the 2 by 3 times of I. Now, you are getting the I1 in terms of I. So, finally, you can replace I1 by what? 2 by 3 times of I. And that's why, finally, V is equal to 8I minus 4 times of I1. 4 times of 2 by 3 I. You can take I common. So, what is the ZTH? V by I. That is equal to 8 minus 8 by 3. That is 24 minus 8 by 3. That is the answer you will get. 16 by 3 ohm. तो चलिए बताइए जरा 16 by 3 ohm कितने लोगों का आया है? How many? How many students got the 16 by 3i? ये है आंसर फॉर दिस क्वेश्चन 16. अब लेंदी है लेकिन आपका 2 नंबर का अगर ये क्वेश्चन है तो यू कैन गेट द 2 marks guys here. You can get the 2 marks in this question. Okay. तो ये तो हो गया क्वेश्चन। नेक्स्ट वन, नेक्स्ट क्वेश्चन में आते हैं जरा। रेडी फॉर नेक्स्ट वन? Okay then. Next question is last question from the network guys. Then ये तो हो गया, आपका आंसर आ गया। अब एक मैंने एनालॉग का क्वेश्चन डिस्कस कर लिया, 3 हम लोगों ने क्वेश्चन नेटवर्क के डिस्कस कर लिए। अब आएंगे राकेश सर, आर यू रेडी?
Yes, sir. I'm ready, sir.
ओके
Just a second, sir.
ओके ओके। तो देखो यहाँ कैलकुलेशन मिस्टेक बस मत करना। या जैसे आपने मान लो रफ में आपने कर लिया होगा तो जो हो गया सिली मिस्टेक्स, उसका तो कुछ नहीं कर सकते। तो थेवेनिन्स लगाओ, डायोड की पोजीशन देखो, आइडियल डायोड दिया हुआ है तो उससे आप इजीली क्वेश्चन सॉल्व कर सकते थे, राइट? तो वहां पर है। ओके डन।
Yes, guys. All right. So, lot of signal and system this time for electrical students. A huge weightage coming up. I think already, 5, 6 questions I have now from signals. Earlier also, I think 1 or 2 I have solved from the signals. Okay, dear. So let's get started. There is a relation when yt is equal to e power minus t integral minus infinity से t e power tau x tau d tau. Okay, then the system is LTI or non-linear, linear or time variant or non-causal. Which of the options is correct? Which of the options is correct? Now, if you have a small manipulation, dear, yt is integral minus infinity से t e power minus t को मैं अंदर send करूं, so it's going to look like e raised to the power, okay, e raised to the power minus t plus tau. तो if I combine, minus of t minus tau हो जाएगा, okay, minus minus tau will be plus tau, okay, x tau, okay. You don't have to check by the basic, system properties. There is a simple method that you can say here. Okay, the simple method you can say here. अब देखो यहाँ पे, the limit is also up to t. The limit is up to the t. Okay, ये जो tau की limit दिख रहा है, tau is less than equal to t as per the limit specified. Okay, tau is less than equal to t means t minus tau greater than equal to 0. So by this motivation मैं ऐसा बोलता हूँ कि let me write down e raised to the power minus t minus tau u of t minus tau, because whenever I write down unit step function, for the unit step to be equal to 1, the argument t minus tau should be greater than 0, and that is what is happening here. So now you can replace the limit minus infinity से infinity, because ultimately when you solve unit step, okay, reverse सोचेंगे, when you solve unit step you will get tau less than equal to t. That is why the upper limit of tau should be t. ठीक है, तो in general minus infinity से infinity if you are writing unit step also, and then x tau d tau. Okay, now what is this equivalent to? Okay, this is x tau. Okay, and this is equivalent to h of t minus tau. Integral x tau ht minus tau. Integral x tau ht minus tau. That means your formula is something of the kind. Your formula is integral x tau ht minus tau. That is a convolution between xt and ht. There is a convolution between xt and ht. Okay, where what is ht? Where what is ht? E power minus t ut. ht minus tau hai, to ht will be e power minus t ut, correct? Now, convolution is applicable if the system is linear as well as time invariant. Linear as well as time invariant. Yes, as far as the analysis we have got. Okay, we'll come to that also, guys. Okay, so whenever the system is LTI, then only convolution can be applied. If any of the property, linearity or time invariance fail, convolution fails. Convolution fails. Okay. Convolution fails. So it is definitely LTI. E power minus t ut, right sided starting from t equal to 0, तो definitely causal भी है. Definitely causal भी है. ठीक है. It is causal also. Okay, because ht equal to 0 for t less than 0. Done है? चलो, so this is one of the question, decent question I will say. चलते हैं next question की तरफ. By the time I've written the question so that we can save some time. E power t square ut minus 1 minus ut minus 10. There is a signal given to you. What is the ROC corresponding to it? Come on, everybody. What is the ROC corresponding to it? So dear, e raised to the power t square. Okay, e raised to the power t square. But what is this xt? It is definitely some function e power t square. This may become unbounded if you go to infinity, but you have only ut minus 1 minus ut minus 10. That makes a rectangular pulse from t equal to 1 to 10. So 1 less than t less than equal to 10. It will be existing from t equal to 1 to 10. That means it is a finite duration signal. And within this finite duration, the signal is bounded. E power 1 or e power 10 square, all of these are bounded values. So it's a finite duration signal with the signal also bounded in that particular duration. So what should be the ROC? Okay, very directly you should say ROC is the entire S-plane. For the Laplace transform, the ROC for finite duration signal is entire S-plane 110%. 110%. आग बंद करके इसको बोल सकते हैं. इसमें कोई डाउट नहीं होना चाहिए. Done है जी? Okay, so check out. I don't have the options. One of the option will be ROC being the entire S-plane. You can also check. Okay, and verify here. Next question, dear. Guys, this is a property you should know. What is the Z transform for x2n या xn by 2, right? x2n या xn by 2. So what is the Z transform for x2n? It is given by x root z plus x minus root z whole divided by 2. ये तो direct आप tick mark कर सकते हैं. Okay, if it was xn by 2, then it is x of z square. Then जी. Then so we don't need to derive any property here. So some questions are simple also, direct result based, the direct property based. Next aa jate. This one is a good question. There are two systems given T1 and T2 such that T1 applied on x gives x0 to xn, summation x0 to xn. T2, okay, xn is x0 plus x1 by 2, etc. plus xn by 2 power n. Which of these are BIBO stable? तो देखो, अगर मैं फर्स्ट को इनपुट आउटपुट रिलेशन के फॉर्म में लिखूं, ओके, लेट्स से इफ द xn इज द इनपुट, xn इज द इनपुट, द आउटपुट इज y1n, एंड व्हाट इज दैट y1n? ओके, या सिंपली yn ही बोल देते हैं, छोड़ देते हैं. फर्स्ट इज आउटपुट yn एंड दैट इज summation of xk. Let me write this way, summation of xk from k equal to 0 to n, from k equal to 0 to n. ठीक है, even, okay, even let xk, okay, equal to a, okay, for all n. Okay, that's what we need to assume, that the input should be bounded. Okay, the input should be bounded. Okay, and let's take the input is finite for all values of n. Finite for all values of n. So what's going to be the value of yn then? It's going to be, dear, it's going to be a, again a, again a. How many times? N times, so it is a into n. Okay, so y of n, kitna aa gaya? That is na. Okay, now if you remember, we have discussed similar concepts in the class. Okay, yn is na. This looks like bounded, but it's a function of time. Okay, the output should be bounded. Each and every value of output for all values of time should be bounded. So time किसी के control में नहीं होता. So if n tends to infinity, when time grows large, yn would also tend to infinity. Although my input was finite. So this one, okay, this one cannot be BIBO stable. This one cannot be BIBO stable. Okay, ये हो गया BIBO unstable. But when you come to the second one में IO relation is given by, okay, यहाँ पे pattern क्या है? x0, x1 by 2, that is x1 by 2 power 1 up to xn by 2 power n. Okay, so let me also again write it in the form of summation xk divided by 2 की power k from k equal to 0 से लेके n, upper limit n तक जाएगा. Okay, once again, okay, let us say, the xn is equal to a for all n. देखो idea क्या होता है? Input should be finite for all values of n. It's not necessary input is equal, but let us assume कि जो भी largest value हो सकती थी input की, okay, it takes that largest value for all n. Okay, that means it is bounded it for all values of n. Then also what's going to be the yn here? yn is going to be summation a divided by 2 power k. Okay, a तो constant है दिया, बाहर लिख दिया. Now when you open the summation, 1 plus 1 by 2 plus 1 by 2 square up to 1 by 2 power n, this time you're getting a GP basically. Okay, sum of n terms of the GP, a 1 minus common ratio is half. Okay, total number of terms n plus 1 ho jayega because I'm starting the count from 0. Okay, divided by 1 minus half. That's okay. So this time 1 minus half ke upar 2a 1 minus half into half power n. But when n tends to infinity also here, even if n tends to infinity, even if time grows large, okay, the yn will be 2a 1 minus 0 because 2 power infinity, a denominator mein hai, okay, 2 power infinity will be infinity, 1 upon infinity 0. So this factor, even if the time grows large, it's a converging series, okay, and output is twice of a. 2 be finite number hai, a to finite hai hi because we assume finite input. Okay, so this is bounded. So bounded input producing bounded output. So T2 is BIBO stable. T1, this is a good question. T1 is not BIBO stable, but T2, which of them is BIBO stable? T2. The T2 system is the BIBO stable. ये अच्छा था. चलिए next question की तरफ चलते हैं. I've written more here. Yes, dear. Xt equal to e power minus of t power 4 cos t minus infinity less than t less than infinity. It has some Fourier transform x omega. Find a d by d omega x omega at omega equal to 0. Straight away, you should think in the mind that frequency differentiation property has to be applied because they are talking about differentiation of the Fourier transform. Okay, so dear, agar xt ka Fourier transform x omega given hai, okay, so what is the frequency differentiation property? txt has the Fourier transform jd by d omega of x omega. Okay, so dear, if I put it like this, suppose y omega is this derivative function d by d omega of x omega. Okay, then what is the yt? Then what is the yt? So in the Fourier domain, if you have d by d omega x omega, j to constant hai, complex constant hai, you divide on the right side. So 1 by j txt, 1 by j is minus j, so that is minus j txt. Okay, that is equal to yt. Now the question is, find the value of the derivative at omega equal to 0. That means find the value of capital Y0. Omega ko 0 yahan pe rakhna hai. So dear, as per one of the basic property of Fourier transform, capital Y0 is also equal to area under curve. Area under the signal, which signal? Yt. Okay, or that is equal to integral minus infinity say infinity. What is the yt? Minus jtxt. Now you might be thinking, sir, okay, xt is a complicated function. Definitely. Okay, xt is definitely a complicated, calculating the integral will be difficult, but don't you observe that cosine is an even symmetric function and t power 4 even power I, that is also even symmetric. So very logically you can say that xt is a even symmetric function. Question solved. तो बहुत लॉजिकल और अच्छे क्वेश्चन पूछे यहाँ पे, योर कॉन्सेप्ट ऑफ हैंडलिंग द क्वेश्चन शुड बी स्मार्ट हियर. ओके, t is a odd term, xt is a even, odd into even function will be odd. So you have minus j integral minus a infinity, that is minus a to a. Okay, integral minus a to a for any odd function is always 0. Is always 0. It is always and always 0. Done hai? It is always and always 0. Chalo, done hai. Next question. Yt is x minus t. Choose the correct option for the convolution of xt and yt. Choose the correct option for the convolution of xt and yt. Okay, so dear, xt convolution yt is equivalent to xt convolution. What is yt? Yt is x minus t. Yt is equal to x minus t. Okay, so that is equivalent to how much? Now, convolution of a signal with its mirror image. अब आप logic apply करोगे again. This is equal to autocorrelation function. Isn't it? Convolution of a signal with its mirror image is equal to the autocorrelation, okay, of the signal. I can write it as Rx tau. It is the autocorrelation Rx tau. Okay. Rx tau, and that's always even symmetric. Proof करने की need ही नहीं है. It's always autocorrelation function is always even symmetric. It is always even symmetric. Done hai ji? Chalo. Next question. Okay, after signals, I have a mux question here. It's again a basic one. Okay, so there is a mux with the inputs PQRS on the 0, 1, 2, 3 input. Select lines X and Y. Choose the value of the inputs PQRS for the function to be implemented as XY bar plus X bar. बहुत simple है. Okay, you have XY bar plus X bar. So what I can do with the X bar, I can multiply Y bar plus Y. Okay, because I need to create all combinations of two variables. There are two select lines basically. So you have XY bar, X bar, Y bar, X bar, Y. XY bar corresponds to 1, 0. X bar, Y bar 0, 0. X bar, Y is 0, 1. Okay, that means the F is in the form of summation of the min terms. 0 aa gaya, 1 aa gaya, 2 aa gaya, but it does not contain min term number 3. Okay, that means I3 has to be excluded. Okay, the correct input combination should be 1, 1, 1, 0. Options honge, wo aap check kar lena. Okay, the correct input combinations has to be 1, 1, 1, 0. The correct input combination has to be 1, 1, 1, 0. ठीक है? चलो हाँ. So next question मैं यहाँ पे बना लेता हूँ. So guys, questions are multiple, but one more from digital, and I think now students are tired after the GATE 2024 complete examination. Questions तो मेरे पास बहुत सारे हैं, but I think let's take one or two and then we can call off for the day. So it is that question. Digital से एक और decent सा question है. Okay, what is that question is? Let me draw. So first of all, there is a combinational circuit given to you, जिसका output होने वाला है S, and the combinational circuit is nothing, very simple, 3 input XOR gate. Okay, 3 input XOR gate, that output is S, and this is the combinational circuit. This is some combinational circuit given to me. Okay, the output of the combinational circuit goes to the input of a D flip-flop. Okay. Output Q bar. The output of the D flip-flop is Z. Okay, and that Z is again fed back to one of the input of the combinational circuit. Okay, that is Z only. Here raha Z. Okay, you are given X is equal to 1, ye fixed hai, and you are given Y equal to 0, that is also fixed. Okay, that is also fixed. All right, now, yeah, this is the clock applied. Question में क्या पूछा है? Okay, present value, that means I can say initially Z is 1. Okay, ठीक है. Neglect the delay of combinational circuit. Okay. Find the values of S and Z. Find the values of S and Z after application of clock. I think केवल 1 clock के बाद पूछा है. Find the values of S and Z after the application of the clock. ठीक है. Dear, देखो, X और Y तो given है ना. What is S? It is X XOR Y. X का value है 1, Y का value है 0. Okay. XOR Z. Okay. We can apply the associative here. No issues in that. 1 XOR 0 is 1. Okay. So 1 XOR 0 is 1. Okay. Bacha XOR Z. And what is 1 XOR Z? What is 1 XOR Z? 1 into Z bar. Okay. That is simply Z bar plus 1 bar into Z. वो नहीं आएगा. तो S is equal to Z bar. ठीक है. S is equal to Z bar. अब देखो क्या बोला है यहाँ पे. ये हो गया initial contents. Okay. Initially Z का value 1 है. तो how much will be the S? How much will be the S? S is equal to Z bar. So S will be equal to the 0. ठीक है. Now, after first clock. Now देखो, S goes to the input of the D flip-flop. Okay, so what is Z basically? Z is the next state of the device and that is equal to D and that is equal to S. Now, that means जो S की current value आ चुकी होगी, that is going to be transferred, okay, to the Z. Okay, so after the first clock, Z will now be equal to the value that is provided by S, that will be 0, and S will be equal to complement of Z, and complement of Z will be equal to 1. So value swap ho jayenge. There is no delay of the combinational circuit. That means as soon as Z converts to 0, okay, at the same time S will be converted to 1 because the delay of the circuit is not, it's given to be 0, neglecting the delay of the combinational circuit. Okay, so after first clock Z will be 0, S will be 1. Options होंगे यहाँ पे, okay, जो कि आप match कर सकते हैं. ओके, जो कि आप मैच कर सकते हैं. राइट. ठीक है जी. सर, you have some questions? So we are done with many questions. Questions तो भी बहुत सारे, but I think students are also tired. So let's call upon Sanjay Rathi sir also, sir, if live, so that let's discuss about some weightage, expected cutoffs, and all those things. Let me also call upon MN sir if possible. Sanjay sir, are you live? Yeah, Sanjay sir is there. Sir, you have any questions, Sanjay sir?
Sir, is it audible?
Yes. Hello. Sir, we are closing if you want to come. ठीक. Yes, sir. Sanjay sir, you have any questions?
No, sir. बस.
Okay, ठीक है, guys.
कंक्लूड करते हैं सर.
हाँ सर, क्वेश्चंस तो मतलब बहुत सारे हैं. मतलब मैथ्स तो बहुत कम डिस्कस हुआ आज. मैथ्स के शायद 2-3 क्वेश्चन ही डिस्कस हुए, बट एक रैंडम वेरिएबल से अच्छा था. गुड, वी डिस्कस दैट. हाँ, एप्टीट्यूड, डोंट वरी इशिता, लेट to be honest guys, all these questions are memory based, but once the response key is released, we will get the official question paper of 65 questions. Then we are going to give you the detailed live solution. PDF तो मिलेगा, but there will be a live video containing all 65 questions for you. Okay, so you don't have to worry about that. Okay, so detailed solution. आप लोग relax कीजिए, आपका भी गेट का एग्जाम हो गया है, पूरी साइकिल फिनिश हो गई है. Okay, so you also need to take a relax here.
एक दो दिन तो एंजॉय करने की बनती है सर एमसीबी.
क्या सर?
मतलब एक दो दिन एंजॉय करने को बनते ही, एंजॉय कीजिए जाइए. अब
बिल्कुल एंजॉय कीजिए. अनलेस यू आर ESE एस्पिरेंट, इफ यू आर टारगेटिंग द ESE, देन आपको एक वीक और वेट करना है. नेक्स्ट संडे ESE का एग्जाम है. तो सर प्लीज जॉइन अस. So देखो guys, 16th February को, okay, the response key will be released by IISc Bangalore. Okay, and as soon as the response key is released, Okay. As soon as the response key is released, the GATE 2024 rank predictor will be live on the BYJU'S Exam Prep app. Okay. So if you don't have the app, download from the Google Play Store, or you can download directly from the description. You go to the description of the video, there is a link. Okay. So however you download, there will be a rank predictor, and you can get to know how much marks you're scoring, and also what is your rank among thousands of aspirants. Okay. So as soon as the answer keys are released, rank predictor will be live. ठीक है, उसके बाद ऑफिशियल आंसर की नाउ 16 को रिस्पांस की आएगा, एंड बेस्ड ऑन दैट रिस्पांस की वी गेट ऑल द क्वेश्चंस आल्सो, एंड वी आर गोइंग टू गिव यू आवर आंसर की विद इन द सेम डे. ओके, बट जो आईआईटी का ऑफिशियल आंसर की है वो 21 फरवरी को आ जाएगा. स्टूडेंट्स आर क्यूरियस, इसलिए डेटा आपको बता रहे हैं, आपने शायद वेबसाइट पे देख भी लिया होगा. ठीक है, नाउ एज सुन एज द ऑफिशियल आंसर की इज रिलीज्ड 22nd to 25th February there will be window to challenge the answer keys if you find any discrepancy. अभी तक जितने हमने क्वेश्चन किए वो तो स्ट्रेट फॉरवर्ड थे, बट वी हैव टू सी ऑल 65 क्वेश्चंस, एंड अगर कहीं भी डिस्क्रिपेंसी है, ओके, वी विल टेक अ सेशन ऑन दैट, सो दैट व्हिच क्वेश्चंस टू बी चैलेंज, व्हिच इज नॉट टू बी चैलेंज, तो आपको पूरा बता देंगे. ओके, एंड सो दैट यू नो इफ देयर इज सम डिस्क्रिपेंसी, मार्क्स टू ऑल कुछ होना है या कुछ क्वेश्चन में करेक्शन होना है, वो आपको पता चल जाएगा. ठीक है. सो गाइस नाउ आई कॉल अपॉन चेतन सर एंड ईशान सर. सर थोड़ा सा एक बार बताइए कैसा लगा पेपर का लेवल आप लोग का, बिकॉज यू बोथ बिलोंग टू दिस द कोर एरिया, सो दैट लेट्स गिव सम हाइलाइट्स टू द स्टूडेंट्स. सर
एक्चुअली पेपर काफी ज्यादा टफ था, मतलब कि प्रीवियस ईयर के कंपैरिजन के अंदर मतलब कंपेयर करेंगे तो टफ पेपर था. लेकिन हाँ, हाईएस्ट मार्क जो आए थे, जैसे लास्ट टाइम 66 आए थे, तो इससे मे भी हो सकता है कि इससे अबव जाए, लेकिन जो कट ऑफ है वो यही रहेगी. हो सकता है इससे नीचे भी जाए, लेकिन ऑप्शन नहीं है.
और से ऑप्शन तो नहीं जाएगा. सो सर हम क्या कट ऑफ एक्सपेक्ट कर रहे हैं? तो मेरे अकॉर्डिंग टू मी ऑल्सो, ओके, सिग्नल्स काफी ज्यादा पूछा गया, बट नॉट डिफिकल्ट. इट इज गुड. I'll not call it as difficult. लेंदी नहीं है, ट्रिकी है. Some questions are for property based also, but some questions are tricky. Okay, वो ट्रिक को क्विकली एग्जाम हॉल में अप्लाई करना सबके लिए नहीं होता. ठीक है, अदरवाइज सिग्नल्स इज नॉर्मल, बट थोड़ा सा ट्रिकी है. ठीक है, कंट्रोल सिस्टम जितने क्वेश्चंस देखे इजी थे. ओके, मैथमेटिक्स ज्यादा डिस्कस नहीं कर पाए, बट क्वेश्चंस मैंने देख लिए. मैथ्स इज आल्सो नॉर्मल, नथिंग डिफिकल्ट इन मैथ्स. एप्टीट्यूड मैं देख ही नहीं पाया, टू बी ऑनेस्ट. ओके, मतलब ध्यान नहीं दिया अभी मैंने, बाकी टेक्निकल सब्जेक्ट्स देख रहे थे. सर कोर कैसा रहा अकॉर्डिंग टू
I
यू?
feel core was easier compared to the last
काफी.
year. Core was easier. I mean, if you talk about machines, power electronics, power system, the questions were easier, and most of the questions were like a repeated concept from a last year. So that was the easier side. But I guess the non-core subjects है, वो थोड़ा lengthy and difficult हो गया.
पावर सिस्टम आई थिंक थोड़ा सा लेंदी पूछा गया है, लेकिन मशीन में तो 4 ही क्वेश्चन आए थे, तो 3 तो बहुत ज्यादा इजी थे, एक क्वेश्चन हल्का सा ट्रिक.
व्हाट अबाउट पावर इलेक्ट्रॉनिक्स सर? वो
Power में बहुत much easier.
मच
Compare देखा जाए तो
क्योंकि
direct
स्टूडेंट्स के लिए वो
question based.
डिफिकल्ट, मतलब इट्स अ बैलेंस देन.
Direct
कोर की जगह ये नॉन कोर को
Non-core
ज्यादा
को
वेटेज दे दिया गया. ठीक है, बट मैं उसको नॉन कोर को बहुत डिफिकल्ट नहीं बोलूंगा. ओके,
लाइक मेजरमेंट में से भी 2 ही क्वेश्चन पूछे गए,
ओके,
मतलब बहुत ही कम क्वेश्चन.
डिजिटल हाँ, डिजिटल में बोलूंगा डिफिकल्ट नहीं है. इलेक्ट्रॉनिक्स के पॉइंट ऑफ व्यू से बोलो तो इजी है, बट इलेक्ट्रिकल के पॉइंट ऑफ व्यू से बोलेंगे तो डिजिटल गुड है, बिकॉज नॉर्मली व्हाट आर द क्वेश्चंस कमिंग इन डिजिटल, एक दो सिंपल सा क्वेश्चन बूलियन का दे देते, खत्म हो जाता है इलेक्ट्रिकल का डिजिटल. ठीक है, बट यहाँ पे एक मार्क्स का क्वेश्चन है, वो तो सिंपल है. ओके, बट देयर इज अ क्वेश्चन जो हमने लास्ट डिस्कस किया, वो इलेक्ट्रिकल के लिए गुड है, ईसी के लिए सिंपल है, जो डी फ्लिप फ्लॉप का क्वेश्चन है. ओके, तो कंसिडरिंग इलेक्ट्रिकल, डिजिटल भी डिसेंट दिया है यहाँ पे, नॉन कोर को ज्यादा दिया है. चलते हैं सीधे संजय राठी सर की तरफ, जो कि भिलाई से लाइव खड़े हैं हम लोग के लिए साथ में यहाँ पे. सर व्हाट अबाउट एनालॉग नेटवर्क, व्हाट इज योर ओपिनियन ऑन दैट?
Sir, when we are considering the question from analog, ऐसा था कि सॉल्व है, मतलब ऑलरेडी आ चुके हैं वैसे क्वेश्चंस. लेकिन अगर आपने उसको ट्रिक नहीं लगाया और नहीं बनाया, तो अदरवाइज ट्रिक के साथ बहुत ही इजीली सॉल्व हो जाते हैं एनालॉग के क्वेश्चंस. अगर नेटवर्क की बात, तो नेटवर्क में भी आप क्वेश्चन देख लीजिए, दैट इज वन ऑन वन म्यूचुअल इंडक्टेंस. दैट वाज लेंथी, बट दैट वाज ट्रिकी आल्सो. जैसे कि मैंने भी सॉल्व किया, तो वो बहुत ही, अगर आपने उसको ध्यान दिया होगा तो विद इन 1 मिनट और 2 मिनट्स में आप उसको सॉल्व कर सकते थे. लेकिन जैसे ही वॉच करेंगे तो लगेगा लेंथी है. तो ओवरऑल इजी टू मॉडरेट.
ओके, इजी टू मॉडरेट.
जिन्होंने पेपर बनाया था वो नॉन कोर वाले थे.
हाँ, मे बी सेम सर, सेम आई एम टेलिंग फॉर सिग्नल्स. ओके, कि मतलब जिन्होंने ट्रिक से हैंडल किया उनके लिए इजी है, जो डिराइव करने चले गए, जिनको सीधे सीधे ट्रिक्स नहीं पता थी, उनके लिए लेंदी हो जाएगा. ओके, सो अब देयर आर मल्टीपल फैक्टर्स टू कंसीडर कि कोर इज इजी. ओके, कई बार पावर इलेक्ट्रॉनिक्स में बच्चे मिस आउट कर जाते हैं, वो इस बार इजी हो गया. नॉन को थोड़ा डिफिकल्ट हुआ, एंड प्रोवाइडेड द नंबर ऑफ एस्पिरेंट्स आल्सो वी डोंट नो राइट नाउ. अगर नंबर ऑफ एस्पिरेंट्स थोड़े से भी डिप होते हैं तो कट ऑफ ऑटोमेटिकली राइज होता है. ओके, तो ऑलमोस्ट ऑन द प्रीवियस लाइंस, बट मेरा ये एक्सपेक्टेशन है कि एक रेंज लेके चलते हैं, बिकॉज नंबर ऑफ एस्पिरेंट्स आल्सो नॉट नोन, सो बिकॉज ऑफ दैट आल्सो कट ऑफ में इंक्रीज बाय 1 और 2 मार्क्स. ठीक है, और कोर इजी है, इसकी वजह से भी एक फैक्टर आ सकता है. तो सर व्हाट डू यू से संजय सर, 25 to 27 आई थिंक कैन बी द कट ऑफ फॉर दिस इलेक्ट्रिकल.
नंबर ऑफ कैंडिडेट भी थोड़े चेंज हो रहे हैं, और साथ में जैसा कि सर ने बताया कि अगर आप इलेक्ट्रिकल पॉइंट ऑफ व्यू से देखेंगे ना, तो क्वेश्चन जो नॉन कोर वाले हैं वो ऐसा स्ट्रेट फॉरवर्ड नहीं बनेंगे।
हाँ,
ट्रिक
स्ट्रेट
अगर
फॉरवर्ड नहीं
लगा लो
बनेंगे
तो बन जाएंगे, लेकिन हर कोई ट्रिक नहीं लगा पाएगा।
सर, उसीलिए मैं ट्रिकी बोल रहा हूँ। मतलब इफ इट वाज अ
हाँ।
इजी पेपर ना, आई वुड बी कॉलिंग इजी। मतलब फैकल्टी के लिए तो सब इजी होता है, लेकिन
हाँ।
अगर इजी का पेपर होता है तो उसको रिलेटिवली बच्चों के लिए भी रिलेटिवली इजी बोलते हैं, बट प्रोवाइडेड डबली, ओके, तो विल कॉल इट एज मॉडरेट टू गुड पेपर फॉर द
तो
नॉन कोर।
आसपास ही जाएगा सर, 28, अराउंड 28।
हाँ,
25
25 to 27 या 28 थोड़ा सा कंसिडरेबल रेंज हो
जैसे सर
जाएगा।
लास्ट टाइम क्या हुआ था, लास्ट टाइम पेपर टफ था, लेकिन अब जैसे टॉपर के मार्क्स भी 66 आए थे, लेकिन इस बार क्या है, जिसका सिग्नल वगैरह स्ट्रांग है, एनालॉग स्ट्रांग है, वो मार्क्स अपने टॉपर है ना 66 से ज्यादा अबाउ स्कोर कर लेगा, लेकिन एवरेज मार्क्स कम रहेंगे।
एवरेज मार्क्स कम रहेंगे, ठीक है, बट टॉपर मार्क्स आई थिंक मेरे को लगता है 70 क्रॉस करेंगे। इट विल नॉट बी रेस्ट्रिक्टेड टू 66, क्योंकि लास्ट ईयर मैथ्स भी बहुत अच्छा आया था इलेक्ट्रिकल पेपर में, बट दिस ईयर मैथ्स इज आल्सो नॉर्मल जितना क्वेश्चंस मैंने देखा। ठीक है जी, सो दैट इज हाउ इट इज, दैट इज व्हाट आई थिंक। सो इसके अलावा स्टूडेंट्स को कुछ और इंपॉर्टेंट अपडेट्स हम यहाँ पे देते चलते हैं। सो रैंक प्रेडिक्टर हमने स्टूडेंट्स को बता दिया है।
अपने कोर के साथ साथ जो साइड वाले सब्जेक्ट है उसको भी ध्यान दें।
नहीं, ये सर सीख होगी नेक्स्ट टाइम के लिए।
So dear, one more announcement for you now. One more announcement for you now is that ये तो बता ही देंगे, but 18 February, I think वो slide यहाँ पे नहीं है, otherwise मैं show करता। 18th of February, that is the next Sunday. Okay, we will be having engineering services prelims analysis, ESC prelims analysis, paper 1 and paper 2 both. Okay, paper 1 and paper 2. Paper 1 का combine करेंगे because it is common for all branches. Paper 2 you will see branch wise sessions for EC, for EE, for mechanical, for civil, all branches. We are going to have the 18th February on Sunday evening, okay, the complete analysis for the engineering services prelims. ठीक है, also at the same time, अब आपका target ESC prelims है तो एक हफ्ते आपको इसमें लगना है, but if your target, okay, but if your target now is कि गेट के बाद आपको और क्या opportunities है, like BARC is going to come up the next month, several other PSUs are going to announce the exam, and based on the marks अभी कुछ आपको अपना एक estimation आ गया होगा कि how your paper was, and as the response key is released आपको almost एक accurate answer मिल जाएगा कि how much marks you're getting. So based on marks, what rank at what marks, what IITs you can get, what NITs you can get, या are you in a position to get PSU, ये सब कुछ हम डिस्कस करते जाएंगे पोस्ट गेट गाइडेंस सेशंस में, एक्सक्लूसिवली ऑन द बायजूस एग्जाम प्रेप ऐप। डेफिनेटली कुछ पोस्ट गेट गाइडेंस सेशंस यूट्यूब पे भी होंगे, बट इस बार बायजूस एग्जाम प्रेप ऐप पे कई सारे पोस्ट गेट गाइडेंस सेशन होने वाले हैं। ओके, सो दैट एट व्हाट मार्क्स व्हाट कैन बी एक्सपेक्टेड, इट्स नाउ द टाइम फॉर यू टू डिसाइड कि गेट हो गया, अभी 2-4 दिन आप आराम से फुल ऑन रिलैक्स करो, बट आफ्टर दैट व्हाट शुड बी योर नेक्स्ट स्टेप। ओके, तो वी आर गोइंग टू डिस्कस ऑल ऑफ दैट इन दिस पोस्ट गेट गाइडेंस सीरीज। ओके, एंड नाउ इन केस you or your juniors are planning to prepare for gate 25 or 26 any of the course, okay, so BYJU'S Exam Prep app पे दोनों courses available हैं for gate and ESC, and also in both the languages English as well as Hindi. You can choose a language of your comfort. Live classes मिलेगा with the facility of recorded lectures, also study material, mock test, practice quizzes, everything to make you exam ready. Okay, if you enroll, you're just exam ready with all the products provided to you. Okay, but still if you want to know more about our courses, okay, so you can have the 1-to-1 counseling and also the complete guidance. Other than the course, if you need any guidance also for GATE or ESC, अगर आपको कोई doubts है कि किस direction में GATE और ESC आपको लेके जा सकता है, anything, yeah, if you want all product features of BYJU'S, just contact this number 924-133-666, और एक छोटा सा काम कर सकते हैं, कॉल नहीं करना है तो you can just fill up this counseling form in the description of this video. छोटा सा basic format, it will take 20-25 seconds. Fill up the form so that our team will automatically book the counseling session and guide you accordingly as per your needs. हर students की needs और temperament अलग अलग सा होता है. Okay, all right guys, so cut off की बात हमने कर ली है. That's it from our side. Yes sir. Sanjay sir, so we are concluding then.
Yes, sir.
Yes. So guys, see you in the ESC analysis also. Okay, next Sunday को हम लोग ESC analysis के साथ वापस आने वाले हैं, and yeah, wish you all the best for the ESC, wish you all the best for the upcoming BARC examination, या जो भी आपका अगला टारगेट है, wish you all the best, relax कीजिए, okay, आपकी मेहनत रंग लाई होगी, I just wish and hope, and that's it.
और सर इस पेपर से हो सकता है उन बच्चों का भी फायदा हो गया जिनका सिग्नल अच्छा था,
हाँ,
कि ESC में हो सकता है कि जिनका कोर अच्छा हो, उनका चल जाए,
उनका चल जाएगा। होता है, there are some several electrical students जो सिग्नल मैथमेटिकल सब्जेक्ट्स को जो enjoy करते हैं, ठीक है, तो वो उनको वहां पे बेनिफिट मिलेगी।
Okay, guys. Then.
ओके गाइस, बाय बाय, गुड नाइट, थैंक यू, स्टे सेफ, एंजॉय करो, मस्ती करो 2-3 दिन। अगर आपका ESC नहीं है, ESC है तो कल से ही आपको वापस पढ़ाई पे लगना है।
और सेशन जरूर अटेंड कीजिए, जहां पर मैं आपको बताऊंगा कि 6 डेज को इफेक्टिवली यूज कैसे करना।
Yeah, tomorrow there is a general session by Sanjay Ratisa to all the ESE aspirants. Okay, tomorrow you can attend this session, and not only this session, guys. There is another session tomorrow at ICT. जो पेपर 1 के कुछ टॉपिक्स है, ICT है, मटेरियल साइंस है, मैथ्स एप्टीट्यूड जो ESE में आता है पेपर 1 में, उन सबके लिए कंटिन्यूस वीक में सेशंस है. तो this week we are going to offer the sessions dedicated for the engineering services. All right, so stay tuned to BYJU'S Exam Prep YouTube channel.
Bye guys.
Okay. Thank you, everyone.